we go. I'm live. Now I can do this. We're going to start by doing some homework that I very much so need to do. Just need to get it done. We're gonna do the homework first, and then we're gonna switch over to switch back to the other stuff. Okay, so starting with homework. Let's see. What was the homework? Workbook, page 16. 15, 16. Here we go. Okay. Okay, and that is this one? No. God damn it. These things are difficult. Page 38. Oh, here we go. All right. Where was the Let's see. What is the homework? Uh Takashi Ta Ta Kashi Sonen Ho Sanha Sanen Sanenha Sanenha. E Where is that? Hello, I am Look at Takashi's profile and describe this in Japanese. What page would this be on? Oh. Ah, I see. Oh, it's San. Sanwa. Takashi Sanwa. Give me a second. I have a paper. Where did I put it? Okay. How did I end up with somebody else's stuff? I'm gonna have to take that back to her. There we go. Wait, this isn't it. There's like a section of this book that has all of this information on it. Japanese. Main characters. There it is. 46. Here we go. So I'm gonna go year, or sorry, I'm gonna go nationality, year, age. Probably. Just look at the profile and describe him in Japanese. Ah, I hope you guys can see okay. I don't know if you guys can see okay. Let me take a look. Oh wait, I forgot to do something. Activate source. Activate source. There we go. So here it is. Sanwa. So Takashi-san, Takashi-san, and then it'd be wa, and then America Jin desu. But in this case, it would be Nihongo Jin desu. So see, it would be ni Nihonjin. Do, 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 do. Nihon, Nihongo, Nihonjin. There it is. We go Nihonjin, and then we do des at the end, which is that. That, and then su. There we go. Then we do, what would it be? It'd be, he is a 4th year. So it'd be Yon. So Yon? No. Zero, ichi, ni, san, yon, go, roku, nana, hachi, kyo, ju. Ichi, yon. 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 See. Yo. Ni. Ne. Si. Yonensi. Ichinensi. Ah, right. Yonensi. So he would be yo. And then and then also deaths. And we'll do his age, which is going to be 22, which would be oops, where is it? Ni. Yeah, so this would be Ni Ju Isa Nisa. Yeah. Okay, so this would be if I move this one up here, we can I can write better. So this would be Ni Ju. This is a character I've not written potentially right. And then the extended O there. Or U, sorry. And then here is where we get into the ni sa. Yeah. So instead of that, we use that, which would be ni sa, and then des. Using the framework X, so X, Y, des, translate the following sentences into Japanese. Ogawa is Japanese. Fuck, that's hard. Holy shit. That's really challenging. I have to do fucking fuck. God damn it. Give me a second. How many pages do I have to do for this? 16, 17. Okay, so it's only these 2 pages. Okay, so if we go back to here, sun. So this would be Ogo wa san. So let's go back to that page and we'll leave that page open. There we go. So this would be O, and then it would be ga. And then it'd be wa. Wait, uh, there was a thing that had the main characters, right? She's not in here. Yeah, she's not in here. Okay. What is this one? Wa san, which is sun. Wa Nihonjin. Ni o Japan. And then G. There we go. Mr. Taka Takada is a teacher. So this would be this. So we go do. And then da is da. Da is, which one was da again? Ah, yeah. Da is Oops, I did that wrong. Da. Wa. Oh, fuck, I forgot. I did that wrong. And then it's san. Oh, no, it's sensei. Sorry. Sensei. Uh, Let me just rewrite this so it's not so fucked up. Oops. Ta. Ke. Da. Sen. Say. Okay. There we go. Sensei. I am an international student. Watashi wa ta shi. Wait. If we're supposed to follow this, this is wrong. Fuck. I'll come back and do that one again. Watashi. I think this is right. I might be wrong. Watashi wa. Yeah, because it would be wa. And then international student. International student. There we go. So this needs to be rewritten again. Fuck. Okay, so this is ta. Da. Sen. Wa. Sen. Say. Haruna is a first year student. Haruna is a first year student. So this would be ha. And then we gotta find ru. I've not gotten to ru yet. Ru. Ah, ru is. Oops. Oh, we continue and then we loop back on itself. Here we go. Ru. And then it's going to be that, and then it's na. Let's just do organic. Ru, and then na. Na. And then this would be san. Wa. And then it would be ichi ne nsi se. Ichinen ichinense. Ichinense. Chi ne nen say. Mr. Yomamoto is 25 years old. Oh wait, we don't need this. No, because yeah, we still put a san, right? So where's ya? Ya, that was a hard one. Ya. And then ma is it doesn't have ma. Right, ma. Ya ma mo. If I remember correctly, we do that and then we cross it. And then to is and then a circle, half circle. Yeah, it was right. Sweet. To. Mato-san wa 25. Oh, 25 is going to be is tricky. Say that I don't actually really mean it like that. Ni ju. Oops. Give me a second here. Ni. Ju. And then 5. Go. Go. And then it's years old. Years old is sai. Sai. There we go. What's up, Fox? I'm doing my homework. I'm horrible at it, but I'm doing it. Okay, look at the chart on page 46 and complete the conversations. 46. Oh, they wanna slowly kill me here. Okay, first, let's see here. This is Mari-san, wa first year student. I I she then say. Oh, interesting. Wait, do we just circle the right one? In e e hmm? Yeah. Oh, right, because we're saying wrong. Yeah, okay, that makes sense. I get it now. We're not just okay. Okay, yeah. Uh whose name is that one? Oh, that is Yamatashi. Yamatash Yamatash Yamashita. Yamashita. Yamashi Shi Shita Sensei. Wa, how old? 47. uh 48, which would be yon. Yon. G. What was it? It was 47, right? 47. Yon. Ju. Okay, Yan. Yon. Ju. How are things, by the way, Fox? Yonju. Nana. We do this. Na. Na. Sai. Um, in school. What year in school? This is whose fucking name is that? What? Is that Mary? That's not Mary. Oh, wait. That's what is that? That one is a saw? No, that's row, right? That's an R. Row, row, oh, Robertson. Rob, Rob, Roberto Sanwa years in school. Roberto. Oh, there it is, right there. 3, Roberto. Sanwa in school. He is a 4th year. So it's do. Then we come down. Oops. Yeah, like that. And then we loop around and we. There. Ask the right question in each of the following exchanges. What is this? This is Yol. And this one is me. Nah. Right? Nah. Yeah, nah. Necesitas. No necesitas. Ask the right question in each of the following exchanges. This would be wait, what? This is wrong. Damn it. This page is super confusing. Okay, wait. So how old? Yeah, okay. So this one is uh ta te shi Tatashi san Japanese. Hai Nihonjen desu. This is hi. Right? I feel like it should be give me a sec here. Ah, okay, yeah, I was gonna spell it wrong. It's ha I hai. And then it's Nihonjin desu. Ni o shin desu. There we go. Nihonjin desu. This one's correct, right? Yeah. And then this still needs a des at the end. Des. Nihon yo nensei des. So this would be why are they making us do Roberto? Yeah, it's only Roberto that's a fourth year. So it is Roberto wa right? Unse das. Unse das. Okay. Unse das. Nense das. Would it just be Nense das? Fuck, I don't remember. I gotta start doing this when I get home. Yo das. Nanban das ka. Nanban das ka. Nense das ka. Nense das ka. I want to say that it's Nense, but I think that's years old. Nanse das ka. Yeah. Years in school. Oh, here we go. Ni nense des. Oh, there it is. Ni nense des. Wa. And then it's na nense des ka. Na nen nen mm, eh, des. And then it's ka. This is G. This was G. No, it was Ju. Sa. 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 Oh, wait. I think I know what it is. I think it's 19. And it's Mary. Yeah, there it is. And then this is the years old thing, right? There it is right there. So this would be I don't think I'm quite getting these right, but I'm trying hard here. Mary's name is fucking hard. Son. Wa. In. Sai. Des. Mari san wa nan nan sai sai desu ka? Nan sai desu ka? Nan sai desu ka? Fucking hard. Okay, and then we've got one more page that we have to do. But luckily that page is very easy. 123. 123. This is an easy page. Nani nu ne. Oops, I did that wrong. No. no, 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 ha, 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 he, 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 who, who, he, ho, there you go. Nani nune no, ha he hu, ha, ha he hu he ho, hu he ho. Ifu, I, o, one, one, B. Leaf is, kono, ho, kono ho, kono ha, kono ha, leaf, kono ha. Na, ni, ka, nani ka, something. Shi, nu, shinu, shinu, die. Wow, morbid. Heta, heta, heta. Let me see. See, write the word below in hiragana. U, ni, ne, hana, ha, na, nu, no, nu, 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 yeah, and then no, hosho, hoshi, hoshi. No, that's not she. Is that she? Oh, it was she. Sweet. Eh, so. Who is? Yeah, I was right. There we go. All done. Beautiful. I'm gonna have to do more studying. Slacking off a bit too much. All right. Now that that's done, we can get back into Unity. I have school tomorrow. That's why I had to get it done today. School tomorrow. Oh, I gotta get it done today. All right, where were we? Starting Wednesday, I'm gonna start doing Japanese in the morning, and then I'll switch back, and then I'll switch over to Unity. There's computation errors? Oh, right. This is not supposed to be that. There we go. All right, so what we're gonna do, I want to be free. I want to be free. Unity dots, and we'll blow that up. But we're gonna go to Unity dots tutorial. It was this one. And then what we're gonna do is Unity dots random values. I don't like this video too much because I think it's just because of how old it is, though. I think it's just a little old.
I'd like to talk about the random class and specifically how to generate random values found in the Unity engine. Because at some point in your game, using random values, is a necessity, if not a good idea to solve certain problems.
Hey, this is so random.
Best practice. So he was pumping.
Okay, so moving over.
So it's effectively what he's suggesting is exactly the way that I wanted to do it, right? But he knows how to get the entity ID.
Unity setup. Basically, again, I'm going to show you kind of the incorrect way to do this real quickly. So this is where we have kind of like a central random controller. So you can see here that I've set up this just real simple game object with the convert entity script on it. It also has this central random data authoring script. And you can see what this central random data authoring script looks like. We just have a public random called value. Then you'll see up at the top, I have this using random equals the unity.mathematics.random. The reason we do this is because there's like 7 different random libraries that we could be using. So we want to specify that we're using the unity.mathematics.random. So in this example, the red capsules are going to be the ones that are getting their random values from that central random controller. You can see basically all they have is this convert entity script on there, as well as a central random tag on here, just so we can filter out by that specific tag. All right, so real quick, this is the incorrect method of doing this, so don't pay attention to it too much. But in the onStart running function, we're basically just going to go ahead and get that singleton for the central random data. We're going to value manager. Okay, so now for the correct way to do this, basically we're going to be doing this on the green capsules. So we have the individual random capsules.
This entire part of the video should probably be checked out because you should
each have an individual random data authoring on there. So you can see that each one of these capsules has its own random value on it. Of course, we can set the state here in the editor if we want to. However, we're going to be doing this all through code. And here's the data component here. As you see, we just have a public random value right here. We're going to be adding a little bit more things to it later. So then moving along to the actual individual random system, basically in the onStart running, first we're going to initialize the random seed. So basically we're just going to do an entities.forEach on anything with an individual random data, which we'll call random data. So then we can just do a random.
The system. So the issue that I'm running into when I look at his code is that the system data or system base is not something that I'm using. And I want to know whether or not it's something that I need or if it's too old. Unity dots ECCS random numbers. Seed, the index. So if I do an int index, okay, let's see here. Walk speed, and then public unity dot mathematics dot random rand. Using, there's something that he did that was important for me to follow anyways. Okay, random, using random equals unity dot mathematics dot random. Walk speed, this would be rand equals new, right? Okay, so this is the data component, and this is the system base, which I think the system base is the same as the entity system thing that I'm using. Get on start running. Get singleton. Where's the singleton? Oh, it's central randoms. Which is central random data, which is this, which is okay. And then we initialize the value with an initial state. Okay. And then where is the, how is this getting used? Captured random. Entities with all central random tag for each reference. And then we schedule parallel. Okay, I think I get that. Okay. Now, where's the, okay, so this is the, Okay, yeah. This is the lambda. Instead of doing a lambda, we can do a function, right? So right now I see how that works. So this is our lambda here effectively, right? But we moved it up to here. So it'd be, so if we were to do this, if this would be, we can just do that, and then it'd be entities. Where is he getting the entities from? Damn it. Here we go, a random. Move my tank along a random curvy path. Okay, so there's the, okay, so where's the rand come in? This does not modify the actual position of the tank, only the position at which we sample the 3D noise function. Its own different random. But where's the randomness? We've got no noise, but like, okay, random color. There's no random in this. Here we go. On update, state false, var random, and then we initialize here. And then returns a random color that is visually distinct. Naive randomness would config a single. Okay, I need to bring this into something so I can read it. It's fucking terrible. Okay, what we're gonna do is we're just gonna do this. Hey, look, now we can frickin' read. And then all we have to do is go like this. And look, now we've got no more errors. Okay, so the config. This this require for update means the system only updates if at least one entity with the config component exists. Effectively, this system will not update until the scene with the config has been loaded. Where is the config? Oh, it's this authoring right here, right? To spawn mini tanks, first you'll need to your tanks. You'll turn your tanks into baked prefabs. This makes the tank object and its child objects into a new prefab named tank. Then delete the original tank from the subscene. Next, add your URPM material property base color authoring components to all three game objects. In the tank prefab, the tank, turret, and cannon game objects. This adds the entity rendering URP material property base color component to the entities. Setting the value of this component at runtime dynamically changes the color of the entity. Interesting. Add a new game object in the subscene and name it config. Okay, so this here count. Authoring tank count. The new entity itself doesn't need transform components. So we use transform usage flag equals none. That's fine. Entity, make the prefab entity, the root entity, where, okay, so authoring's here. And this is a config authoring, which is this, and then take tank count. So how do we get, does this actually give us a number though? Okay, so we're going to do that. And then we're going to do this. And he's got int tank count, or they have, and that's like exactly what I want. Unit ID walk speed, or we'll say move speed. Right? And then here, when we do the baker, wait a second. Yeah, okay. Then we have effectively these exactly here. Oh no, that's the count for the spawner. This is the spawn system, that's fine. I think this is the one that I've got, right? Here's the config. I don't care that much about it. We can actually change this because this will be the random move. Instead of config, it's random move. I feel like that's not right, but whatever. Oh, I see. I see what's going on here. Okay, so this is no, this is the on update, and it won't work. Fuck. Wait, we're not. Are we not actually giving these a thing? Oh no, we are, right? Unity ECS dots do entities have a unique ID? T consists of two variables to do. Initially, we store some information about the entity in an array. Wait. Indy get as. Can we get the memory address? 'Cause it's just a number, right? Unity get the memory address of a variable. Is that seriously all it is? We'll give you the memory address. I'd like to get the variable address of a game object using debug log. Int pointer. In order to access an address as a number, you can cast from pointer type to int pointer as an integer type. This is perfect. Oh, yeah. So if we do this, right? We don't need this. Oh, we can do this new random, right? And if we do public random rand, this will give each one of these a random, right? That's fine. Perfect. Okay, so bear with me here. We're gonna not do that. We're just gonna we don't care about that right now. We just only care about this update here, right? And there's our random color. And that's fine. We can actually, what we're going to do is we're actually just going to delete this. This is fine. Get rid of this. I have an idea and we're going to see if this works. Wait, what? This isn't right either. Okay, there we go. Schedule parallel. New this. There's our execute. Come into here. We've got move speed, right? Which is actually random move. We don't have a unit ID, but what we're gonna do, actually, no, we do, but we don't need one. There we go. So what we're gonna do is we're going to do uint int pointer. So it's uint, and then it's int pointer, and then we take a pointer of entity index. Wait, is entity index just a thing? Oh no, it's a thing that I pushed in that doesn't exist. I wonder if I get an int. Do I just get an index? Like, is this a thing? Yeah, that's what I thought. It's not valid, right? So, okay, so if we do an int pointer, pointer to random move speed. Damn it, that's not a pointer. Hmm. Unity ECS get index of entity. Struct entity. Equipable. The ID of an entity. Index of the ID of the entity. The entity is a fundamental part of the entity component system. Everything in your game that holds data or identity of its own is an entity. An entity does not contain either data or does not contain either data or behavior as itself. Instead, the data is stored in the component, and the behavior is provided by the system that processes those components. The entity acts as an identifier or key to the data stored in components. Entities are managed by the entity manager class that exists within the world. An entity struct refers to an entity, but is not a reference. Rather, the entity struct contains an index used to access entity data and a version used to check whether the index is still valid. Note that you generally do not use the index or version value directly, but instead pass the entity struct to the relevant API method. Remarks. Entity index indexes are recycled when an entity is destroyed. When an entity is destroyed, the entity manager increments the version identifier to represent the same entity. Both the index and the version field of the entity object must match. If the index is the same, but in version difference. Wait a second, I think I forgot to do something. Yeah, this would be in. I guess this would be what? Like in? There, and then t dot index. And this is what, an int. So if we cast this to a u, if we do u int, and then we take this and move that to here. And then we can do, this would be what? Random move dot set dot state dot rand dot set state set state set init state. What's up, Box? Switching over to Twitch now. Then we've got our random move dot rand Dizzly day. Not much. Drizzly day. Oh, it's raining. I think it's also raining here. And then this would be random move dot move speed. I feel like this is going to work. Can I log from within here even if it's bad? My entity index. Here we go. This is not performant because we're doing an expensive log in a job, right? And you don't ever want to do that. But I'm okay doing it because I don't care. Okay, let's hit play. And let's see what happens. Did it crash? No, it didn't crash. Reload scene. It's working now. That's beautiful. We reload scene. Oh, it's amazing. Look at that. Current torque. I'm gonna get rid of those torque debugs. Scripts. Debug.log. There we go. Okay, so this should drop there. We don't get that. Oh, okay. We don't get nothing there. It does not pass through the entity. uh yeah, I don't get a an extra entity. So there should be 2 entities in here. There. Okay, so I have 1, 2, 3 entities, right? Though, if I do this, wait. If I do, and we go runtime, entity GUID. Look, that's actually what I want. Wait. Each one of these has a different. Oh, it works. The unit ID works for the move speed. Wait. Where's my move speed then? That worked. Oh my god, that worked. Move speed. Okay, wait. Yeah, okay. I got it working. That's fine. Random move authoring here, and then we do this, and we do unit ID, right? And then we do. Where's our random authoring here? No, where's our move speed? Our move speed's the one. Creation bolts out the sun, blots out the sun for the villagers below. They surely praise it as God, but we know it really to be a functioning 32-bit computer with 2 kilobytes of RAM. It's pretty good, dude. Wait, where were we here? We were definitely somewhere here. Okay, I'm gonna just we're just gonna remove a couple of these. I am not recording. God damn it, I'm not recording today. Fuck. There we go. Oh shit. Now we're recording. Fuck. Okay, move speed authoring has what I want. Here we are. Move speed authoring actually worked the way that I wanted it to. And because it's a baker, it can use the regular random, right? This doesn't need to be like that. This can be that, and then here we want the unity dot No. Okay. Yeah. So what we want is that for the UID. That's fine, right? Then what we want is we want a unity dot mathematics dot random equals new random. We want this to be, this is fine, yeah. And then we're going to pass that in here as rand. And then up here, we're going to make sure that we utilize the correct random. There. Now we have that. And then here we want unit ID equals unit ID. And then the value is going to be the move speed equals authoring dot move speed. So why is this not working? Cannot resolve symbol move speed. Oh, right. This is going to be public float move speed. Then if we go to this cube and we do authoring, we're going to come down here and we're going to do the move speed authoring. We're going to get rid of this. Remove component. And we're going to go to our, do that. And then we can get rid of that for now. We want entities authoring. We want the random move, right? Random move. So we come down and then we add that in there. And we're just going to move that up here like so. There. And then this one we can say is 4. That's great. Perfect. And then we're just going to delete these other ones and recreate them. Duplicate. That did not duplicate. We're going to click here and we're going to duplicate. And then duplicate again. And then we're going to reload current scene. Reload. I forgot to save. Oh, winning. There's my cube. Random move speed. At least it saved that. Okay, beautiful. We're going to do that and then Control D. There we go. Control D. And there. And then we're going to save. And then we're going to reload current scene. We see them. Beautiful. There. And then we're going to switch this to runtime. Entity GUID. I just want to be able to like grab that, the entity GUID, because the entity GUID is like perfect. 8.6. Yeah, the entity GUID is actually great and perfect and exactly what I want. But no, we can't do that. Okay, but we can do this and look, 7.0. And then if we go to do random move, 7.7, beautiful. 8.7.0. Yeah, okay, everybody's got different numbers. Yeah. And then we can get rid of that debug. Okay, so the move speed we can close, and then here we don't need to debug anymore because it doesn't matter. Actually, wait, we might still be able to do this. Is it just good though? Not good? No. Index? We're going to try this because why the fuck not? Reload domain. Let's reload currency. Make sure that everything's still there. Good, good, good. We're going to hit play. Look at that. The entity index is there. Oh my god, they all have entity indexes. I don't even need this. There we go. We don't need this in it at all. And then we can get rid of this. And this. Wait, no, this one's important. This one's not. There we go. There. And then we just init the state here by the entity index. And then yeah, we get a random number. And then we can do this. We'll say 100 and 100. This is fine. I don't like this here. So what we're going to do is we're going to float 3. Target position offset. And then we're going to take this and we're just going to move this up here. Oops. Target position offset. And then this is going to be target position offset. And then this can come up here like so, and this can come down like this. This might be able to go on one line. Yeah, that can go on one line. There we go. Beautiful. And then we can do our debug log. And then this is going to be this, and we're just going to do entity.index. Move target point, new target position. And then we don't need this. We want target position. There we go. And we're going to save and reload scene. And then we hit play. Randa invalid state 0. Ah. Debug.log ID. Well, we want that. And then we want this. So we're going to build. Come back to here, rebuild domain. Reload current scene. Hit play. Check. Here, Steve, get a random seed. It's not what I want. Get the current time as an int. You know what? No. What we're gonna do is we're just gonna do uint. Oops. We're gonna do u because this requires a uint, right? Okay, wait. We're just gonna do 1 2 3 4 as a uint. There, and it's being seeded. Init state. Is this it? Init state? Impure state method called on a read-only variable struct. Ah. Wait, we have the entity. Index. Uint. Redstone is pretty good. It's beautiful. It's actually beautiful. Look at it. It worked. The only thing the curious thing here is we want to make sure that like okay, so that's going to be different than the next time that we see it, right? So 6 6. Yeah, it changes every time. Beautiful. Perfect. It works. Look at that. Shit works. Shit works. It works. It works. There we go. We did it. Now I want to make sure that it's actually being burst compiled. Unity ECS check if system is burst compiled. In the profile, you should see a burst. Can I be sure that burst runs? Using burst compile to compile a job with jobs burst. Yeah. Okay, so I think that Mr. here had some stuff that he was using.
Can use whatever ID you want, but it has to support source generation. If you look over here inside documentation for the entities package, over here we do see a section for IDs. People find quite tricky. So if you ever come across an issue where for some reason nothing's showing up in the console, definitely make sure you check these buttons. Always make sure they are all ticked so you can see exactly everything that just shows up the game view on the center. First over here on the game on this. And also if your game view is only pixelated, then make sure you check out this slider. If you move like this, then this looks really pixelated. So always make sure if it is on center, then it's placed on the center of the that one and everything. Now something else. And preferences. Then over here on the left side, let's go into external tools. And here make sure you select your external script editor. In my case, I don't know to export all the settings. I think the main thing that I changed was really just the rainbow braces. I think I changed some of these colors. Tabs, the advanced, and next. XML, and just go ahead and import this. All right, so yep, with that, you should have your Visual Studio set up exactly like mine. Let's low poly sample space. This, let's assign this material. So let's expand that one and assign that material. Yeah, there it is. And for the zombie, let's also assign this material. All right, that should do it. So here we have both of our units, and they are visible directly over here on the camera. Okay, great. So we have our starting assets imported, so everything's looking nice. Now let's just handle some more visual things. We want to set up lighting, post-processing, and SEO. So let's do that in the next lecture. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to set up post-processing and lighting to make our scene look really nice. Okay, so here we have some assets and we have our camera set up. Now let's make them look nice. We already have the project set up to use URP, so adding post-processing is actually pretty simple. It's already somewhat enabled by default. Here, this scene that was created automatically. This is exactly why one of the huge benefits of DOTS is actually world streaming, meaning how you can have, for example, a huge open world and you can have it split into various parts, and then you can dynamically load and world, and there you go, now it does update. And now we can select, for example, this subscene. And again, another strange box on the inspector. Let's go back into authoring mode and go into run menu. Let's go down here into entities, and we can open up the entities hierarchy window. So
that's what it is. Oops. Tool Windows entities. Here we go. Hierarchy. Oh, that's beautiful. Yeah, I like this. Perfect. It's almost better than just having the hierarchy. Okay, so then we want Windows. Entities. What's archetypes do? Don't know yet. We'll come back to that.
so here it is. This one is very much like the normal hierarchy, except instead of showing game objects, it shows entities. It also has multiple modes like the inspector, and it has a toggle to see various worlds at the same time. Now sometimes this window gets a little bit bugged, sometimes it doesn't update. If that's the case, you can just reselect the world and everything should update. But anyways, the main point is that if you look in the game object hierarchy, with the subscene being unloaded, being closed, this way we cannot inspect the object. However, inside of the entities hierarchy, over here, even though the subscene is closed, we can indeed inspect the entities that are inside of that subscene. Now we still cannot modify it because again, it was baked into binary data. But if we hit on play, if we start playing the game, again, here's the bug. Here, let's switch it into runtime mode. And again, here's the bug, it's not updating, so let's select the default world. And there you go, now it does update. And now we can select, for example, this subscene. And again, another strange bug on the inspector. Let's go back into authoring mode and go into runtime mode. And in the inspector, let's just go into runtime mode. And yep, here we do see the dots components. So the entities, or if you're every system also has a corresponding entity, but don't worry about that for now. We're going to learn about systems in a little bit. And let's see also one very interesting thing. So if we go inside the hierarchy, so the normal game object hierarchy, and let's right click on the subscene, let's create an process. So far we didn't do anything that was specific to dots. And just with this, if now we hit on play, and right away we can see it does work. We can see that sphere fell down and it's now rolling along exactly according to physics. Right, awesome. So just like this, our dots entities already have physics and everything working. So this is really how awesome the baking system is. We just work with normal game object components like we're used to, and then they are automatically converted into entities with dots. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to create a job and use bursts so our movement code is insanely fast. We're going to look at the results before and after to see the really massive difference that it makes. Okay, so here we have our unit. I can right click and tell it to go to some position. So let's copy exactly the same query that we have up here. So we need the local transfer physics system. Just make sure that it's still working and yep, it still moves. Okay, great. So now, and over here we make sure we add burst compile. Then in Unity, let's go into jobs and enable burst compilation. Okay, that's it. Let's enable jobs. So let's go ahead, comment out the system. Work just with the normal for each, just with normal main thread code. First get working like that. and access different positions in memory and stuff like that. But in general, jobs are self-contained, meaning they need to have all the data that they need in order to execute their function. Now, this only works on data that the job has, then it's super easy to make it run parallel in multiple cores at once. So the error that we have here is because we cannot access the time.time from here, and the way we solve this is super simple. We basically just define a field on job. So up here, let's just find a public float delta time. So just a perfectly normal field, and then down here, instead of going through system API, we just use that field. So yeah, that's it, no more errors. So now basically, when we construct our job, we simply need to assign the delta time, and everything will work perfectly. So let's actually do just that. So up here on the on update, let's construct a brand new job. So a unit mover job, let's make sure to comment out the other random query code. Okay, so up here we have defined our job. Now all we need to do is really just run it, and we actually have multiple ways of doing that. Use is one that's comments, and it will split the logic in multiple jobs based on the number. If so, they are unlikely, but you're only running this course, and what you should probably do when building any kind of new system, first make it work just with the normal for each, just with normal main thread code. First get it working like that, and then make sure that compilation is enabled. If you do we schedule it, and let's comment out the rest. Okay, let's save. And over here, let's hit on play and try to move the entity, and yep, everything still works perfectly. All right, great. So the unit is still moving exactly the same, except now it is moving using a really nice job. By the way, what we just did here is actually what we're going to do a lot throughout this course, and what you should probably do when refactor it into a super is up here on the only fast. So let's save and let's test this, enable, let's test, and there you go, everything still works fine. Now let's actually see the difference that all of this makes in real terms. Now this code that we have here, this one is really simple, so it is going to run insanely fast no matter what, so it's actually a little bit tricky to see the results, just because again, everything's going to be insanely. Yep, the mover system is working on 10,000 entities. Okay, great. Now over here in our code, let's make it run the slowest possible. Let's use the normal for each without jobs. So let's actually comment out this one right here, comment out the job, and let's uncomment out the for each. Okay, so we're going to use the normal code. Let's save this. So we are not using jobs, and also let's go up here and make sure to not use burst. Okay, now for seeing how fast it goes, let's go into window, then go into analysis, open up the profiler. So here it is. Now I'm going to hit on play and capture a certain frame. So they're all moving, capture frame. Okay, here it is, and let's see how fast it is. And yep, here we have our unit mover system in total running on 10,000 entities, and it is taking 9.13 milliseconds.
Okay, wait. It was
Okay, great. Over here in our code, let's make it run the slowest possible. Let's use the normal for each without jobs. So let's actually comment out this one right here, comment out the job, and let's uncomment out the for each. Okay, so we're going to use the normal code. Let's save this. So we are not using jobs, and also let's go up here and make sure to not use burst. Okay, now for seeing how fast it goes, let's go into window, then go into analysis, open up the profiler. So here it is. I'm going to
Is this the only way to check? Okay, and then we move this over here, and then we want to see if we can find the waiting for jobs player loop. Where is the interloop? That's fine. Player loop. Call event. You know what? It's probably so small. Find brightest direction. That's not it. we can find it if we click on these tiny things. It's going to be one of these. Probe. Give for render job. It's got to be around here somewhere. Can I do a search? Nope. Do-do-do. Draw shadows. Under execution, wait for jobs. Where's the random here? It might be too small. Might be so small we can't find it. Unity, is there a way to verify my code. Verify a section of code is first compiled. Yes, in Unity, you can verify a section of code is burst compiled by using the burst inspector window, which allows you to view the generated assembly code for a function marked with burst. Open the Unity editor to analyze jobs. Select burst inspector. That's exactly what I wanted. Sweet mother of fuck. Windows. What was it? It was window analyst jobs. Window analyst. It's not there anymore. So good. So good. Rendering. This is something that's not technically needed right this moment, but it's something that I want to be able to like track, right? Because it will give me an idea of whether or not something is going to be burst compiled or not. Burst inspector. Okay, here we go. Of course, they've moved it and not kept up with the documentation. It's beautiful. Just beautiful. Oh, it's under jobs. Pedestrian move system. There it is. The burst inspector will display all jobs and other burst compiled targets in the project. The inspector allows you to view all the jobs that can be compiled. You can also check the generated intermediate and native assembly code. On the left part of the window that provides the alphabetical order sorted of the jobs with burst compile to view these disassembly. Don't really care less about that right now. Just in time, ahead of time. Now, just because it shows up, does that mean that it's guaranteed to be burst compiled at that point? I feel like it does.
Going to hit on play and capture a certain frame. So they're all moving, capture frame. Okay, here it is, and let's see how fast it is. And yep, here we have our unit 0.35 milliseconds. Like it says here, the total amount of time is 0.84, so that's the total amount of time, but since it is running in parallel, the whole thing runs in 0.03 milliseconds. By the way, the green color. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn how to get the unit to move to the mouse position, but only when we click. This requires refactoring our component and creating another non-dot script. Okay, so here we have our unit rotating and moving towards the mouse position, but we want it to only move on mouse click, not all the time, so let's solve that. And for that, we're basically going to need two things. So we need to store the target position instead of setting a new one every time, and we also need to test for a mouse click. Now first, for storing the target position, as always in dots, you store data in components. So let's actually refactor this move speed component to include a bit more data than just move speed. Let's rename this so we can right-click directly on top of the symbol, and let's click on rename, which will automatically rename everything. So let's rename this instead of move speed, just call it unit mover. So this is our unit mover component. So rename that one, and let's also rename the authoring component. So let's rename it, and this one is going to be the unit mover authoring. Okay. Okay, so yep, everything has a different name, and now the unit mover system, this one is also using the unit mover. Let's just rename this one over here, so unit mover. So yep, that field has been renamed, the unit mover has been renamed, and over here we're not using it. Okay, so far so good. Then back in Unity, make sure the file itself did change. It should be called unit mover authoring, and if we go inside the unit itself, yep, it should still have it, and if we hit on play, yep, everything should still move. Okay, great. By the way, here, make sure your unit is not on 0, 0, 0. Move it just a little bit. It's important because otherwise you won't get an issue with the math.normalize. If the move direction is 0, 0, 0, then this one ends up with an end, not a number, and that causes all kinds of issues. This will no longer be an issue once we add the stopping logic later on in the course, but for now, just make sure the unit is not on 0, 0, 0. So on this one, let's add some more data. Actually, let's also rename this one instead of being value. This one is going to be the move speed, and same thing on the unit mover authoring, move speed. Then here in Unity, let's select the unit and make sure that it has a move speed. So there we go, reset to 0. Let's put it on 5, and again, play again, and yep, it still works. Okay, great. So now here on the unit mover, now we can add whatever extra data we want. Like for example, we can add the rotation speed. Like previously over here, we were using a local variable, but it makes more sense for that data, that value to be defined over here. So let's do a public float for the rotation speed. And again, let's also define it on the authoring component so we can pass it in. So our rotation speed equals, go inside the authoring component and grab the rotation speed. Then on the unit mover system over here on this one, instead of using a local variable, instead of that, let's use the one that we get from the thing. So we get the quaternion local rotation, and then for the t, we've got time multiplied by, let's go inside the unit mover component. Let's read from it. So let's access the value RO, and we want the rotation speed. Okay, so now our component should have some more data. And if there's our component with rotation speed, let's put it a bit faster. Let's say 15. Let's test. And yep, it is still rotating with the rotation speed. Okay, great. So this working. Now that's left is to deal with making sure that it only goes towards the mouse position and only on click. Now technically over here on the unit mover system, on this one we could add that logic. So we could test over here if input.get mouse button down. So when player left clicks, if so, we can say the target position equals the mouse position. So technically we could do this. We could write this directly over here, directly inside of the unit mover system. This would technically work, but then it would also become quite messy. One of the main goals of dots is for your systems to be focused on doing just one thing. So for this system, which is called the unit mover system, this one should really only be moving the unit. It should not care about giving unit orders. It should only move regardless of where that target position came from. So let's make sure this system stays focused on just that, just moving units, not on giving orders. For that, let's make another script that will basically handle the unit selection, giving them orders. And again, we have the same question we had a while ago. So do we make that a normal system, or do we make it a mono behavior? Again, going back to general guidelines that I mentioned a while ago, basically how you should use normal mono behaviors when we have something that only happens rarely or is not performed for a second on the mono behavior. Give it the exact same class, access the static instance, and call get position. Okay, great. A regular mono behavior, we just use a static instance in order to access it. Now here we want to do the opposite. We want to access the dot to set memory around until you manually dispose of it. So if you were to make something persistent and then you do not dispose of it, then over here we would be creating a new object. We would be instantiating new memory, doing that every single time we press the mouse button. That would essentially end up with a memory leak and the game would eventually crash. So if we were to use a persistent allocator, then we need to make sure to clear the memory. But we have other allocators, and the important one is over here is the entity, or we can save all the files, make sure they all compile. Let's wait for compilation to finish, and now let's test. So let's hit on play. Okay, the unit is going to 0, 0. Let's just ignore the rotation. Now I right click, and nope, nothing happened. Target position is not changing. I can inspect the unit and go over there onto the runtime mode, and we can find our custom unit mover component. There it is, and yep, target position is on 0, 0, 0. So even as I right click, nope, it does not change. So the problem is right here. I wonder if you managed to notice exactly what the problem was. So the issue is, once again, here we are working with structs and not we're on position. Then as always, let's make a normal game object to run it. So an empty game object with the exact same name. Again, outside the subscene, this is a normal game, and it's slightly downwards, but still just make sure this. Then we can call this function. So let's go back over here onto our unit mover script, and when getting the target position, let's go inside the mouse position, access the static instance, and call get position. And just like this unit.
Okay, wait. Minus. Ah, here we go. Okay. So if we say we want to. Okay, so
it should be going towards the mouse position. Let's make sure to save both files. Wait for Unity to compile. However, after we compile, we actually see an interesting error over here on the console. This is a burst error. It's telling us we cannot use burst inside of this function because inside it we are calling a managed function. We are calling our mouse position.get instance. Once again, when using burst, we cannot access any managed data. So this is why you have to be careful when not using just structs. If you don't, you get this issue, which means the code won't still compile. We can have them play and it will work, but it will not compile using burst, meaning the code will still run just slower. Now, right now in this example, we can really just ignore this error since later on we're going to get the target position in a different way. But this is a great reminder of the limitations on burst. And when working with dots, don't get too scared if you see some burst errors because again, they don't stop compilation. They're really just warnings to make sure that you know that burst is not working. So and collider. And with that, then yep, this would be working exactly the same, but using physics. So
okay, wait. Did I go too far? Yeah. Okay.
Depending on what game you're making, you have two options. You can use physics or not. The standard thing for making this a singleton. Now, since this is an intermediate course, I'm assuming you already know what exactly. However, after we compile our muzzle, the code won't still compile. We can have them play over here in our unit system. We are setting the rotation, and we are setting it directly to the final rotation. If we
okay, yeah, here we go. Okay, so there. We're going to do that, right? So that's going to give us 2 random floats within 1,000. And then they want the target position minus the new. Oh, right, because no, but this should have them moving around constantly, right? So it'd be the target position minus their current position. There. And then we've got the normalize. That's fine. We should never be 0, 0, 0. Ooh. And then move. This would be move direction. This would be this would be local transform dot position dot y. Local transform dot position dot x. And this is z. And then this would be target position minus the current local position. And we can get rid of this log, and we can get rid of this log, and that. There. And then, what's the problem here? Let's complain about. No, not doing that. Okay, and then this would be turning in move direction map up. Yeah, and then to do move speed. Okay, here we go. They're always moving in the same direction. They shouldn't be moving in the same direction. That doesn't make any sense. Right? This doesn't make any sense that they all move in that exact same direction for some reason. They have different values, but they all move in the same direction. Right? So if I do debug.log, right? And then we do entity dot id index, and then we do we do target position, and then we do local transform dot position. That's our current position. And then we do target current. Invalid operation. I had another similar issue. Note that I still see. Let's take a closer look at this and this error. Invalid operation exception. Specified hierarchy node handle does not exist in the hierarchy. What? What? It's here. There's the cube. Okay, wait. Let's clear. We're gonna save. We're gonna reload domain and test it out. Okay. Reload current scene. Object reference. What? What seems to be the problem? Clear, I should reload. I should still see it, right? It was weird. Right, these are going to be the same because we need to get delta time. System. Okay, one sec.
If we want to add some interpolation, we can actually use the slurp function. Here, comment out the job, and let's uncomment out the for each. Is actually what helps write super fast multi-thread code without causing all kinds of chaos. If the job only works on data that the job has, then it's super easy to error job. So a unit mover job, let's call it unit mover job, and construct a brand new unit mover job. And now inside of it, for delta time, over here we can need access system API .time .delta time. And if so, that's our job all set up.
Okay, so we're gonna come up here and we're gonna say, what is it? It's a float. What's it? It was system API time.delta time. And this returns a float, right? Yeah. Okay, so here we'll say float delta time. Did he say that it needs to be private or public?
Let's make mover job and construct a brand new unit mover job. And now inside of it for delta time over here, just use that field. So yeah, that's it. No more.
You did public. I will do public just to be safe. Public. And actually, I want this to be uint. Hmm. There we go. uh, uint delta time. And then
Brand new job. So a unit mover. So that's and we actually have all set up. Let's make mover job and construct a brand new unit mover job. And now inside of it for delta time over here, we can need access system API dot time dot delta time. And
okay, and then here we do this, and this would be uint delta time equals this. Then here, oh wait, no, that won't work. We don't need this. I don't know why I was doing that. That's fine. Although I feel like delta time might actually be useful. So we're gonna pass it in anyways because I'm probably gonna be using it very soon anyways. Public float delta time.
okay, so that's our job all set up. Let's make sure to comment out the other random query code. Okay, so up here we have defined our job. Now all we need to do is really just run it, and we actually have multiple.
Oh, there it is. It's the slurp.
ways of doing that. Now, the most straightforward one is go for the unit mover job and just call run. Now, this one will run the job directly on the main thread. So this kind of was the main point behind jobs. You should probably only use this one just for testing or debugging. Essentially, this one ended up pretty much the same thing as we had previously. The main goal of job is to make multi-thread code. So usually the one that you want to use is the one that's called schedule parallel. This one will schedule the job to.
Okay, so we're going to compile this. And we're going to come back to Unity. And reload current scene. We're going to see our errors probably. We don't see errors. Okay, that's good. And yeah, that's still doing weird things. Okay, so this is actually providing multiple. Sorry, this is actually providing multiple. Like it's happening multiple times because this is saying that 3 times it gave us this, right? For 97, and then if we look at this 97 and that 97, they're different. So we are getting different numbers. Just the numbers aren't very different, right? Like look how close these are. Target float is like almost the same. These are like barely changing. It's supposed to be giving me does this have a let's see, okay, so random move dot rand dot move dot rand dot let's just say next float 3. Float 3 target position. We'll do that, and then here we'll say target y equals there. Okay. I forgot to hit reload soon. They're still all moving in the exact same direction. Okay, 1-1. I'll be right back. I am back. Hey, Chrono. Welcome back. So I largely got stuff back, but now I need to read the documentation for unity.mathematics.random. Okay, so if I do a float 3, is this a float between 0 and 1? And it kind of feels that way. So I think what I want is not a float 3. I want ints, right? So I want like an int 3, right? Yeah, so I got the RAND working, and I didn't follow that guy's documentation on how to get the RAND working, but I was right. I was like entirely right. I just didn't realize how I was going to do it. But also like my idea of like how I was going to do it was very similar or potentially exactly the same as the way that guy suggested it. So what you can do, figure this one out. Okay, so what I did was if I do, we can go to random move, right? Here. So we have our rand, right? So this random value is stored. That's fine. No issue there. And this does get updated, which is great. So every time you run it, you get a new random number. And we initialize it using the entity.index. And we find out that entity has an index that we can access. So what we do is we pass in this in entity, and that gives us the entity. And it gives us the index of the actual entity in the world. And I was like, there has to be effectively a GUID to track every single entity. And I was right, there is. It's entity.index. And every entity has an entity.index. But how do you get the entity.index? You get it by making sure that you pull in the entity struct. As long as you pull in the entity struct, you're golden. Those ghost variables. I don't know if I'd call them ghost variables, but because they show up, right? So like if I go to the entity hierarchy and I click on this, we go to runtime. Does this need to be runtime? This pedestrian spawner. Here we go. Yeah. So if I go here and we look at it, where did it go? These don't even have the thing that I want. Editor rendering. Here we go. Entity GUID. There you go. Yeah. So as long as we have the entity, I tried entity GUID and it doesn't seem to like that, right? So if I do entity dot, we have index returns an int. That's fine. But like I don't really have a whole lot of other stuff here. So I'm guessing that it's just the index, right? And then if I jump to it, yeah, so it's just the index. Beautiful. I don't, is there a hash code? I feel like we want to avoid getting that though, but it returns the index anyways. So we can just call entity.index. Okay. Anyways, so that gives us our randomness. Now the issue that we're running into is that if we look at, is this the mathematics? Yeah. Okay. So if we look at float 3, I think is only giving us back numbers between 0 and 1. So this is floats. I want random. Next, float 3. Turns out, yeah, between 0 and 1. I was right. Returns a unit length float 3 vector representing a uniform random 3D direction. Yes, that would work. This is also kind of cool too. Okay, so what we're gonna do is next float 3, and then we pass in a float 3 min. So this would be new float 3, and this would be 1F 1.0F. And a circle too. Oh yeah, his circle stuff. 0.0F, 1.0F, and then there we go. Hell yeah. Now we build this. We go into our editor. We reload current scene. We hit play. Oh my god, it worked. One. We get to a point where like each one's getting it 3 times before it gets to the next one. Yeah. Yeah. Or no, because yeah, you're right. So it'd be negative 1,000. Negative 1,000. There we go. Yeah, but the formatter doesn't always do what I want. Okay. Then we come over to here, reloading domain, running background. Beautiful. We hit play. It's beautiful. It worked. It worked. It frickin' works. Okay. Now we can do the spawner. Mhm. I'm gonna clean this up a little bit because I've got way too much going on here. Do this is the learn dots. This is the important one. We can come over to here. This one here, I don't think I need anymore. Yeah, this one I don't need anymore. With the exception of that. Let me just go like that. We can do that. Rem is currently streaming. Oh, look, he's making oh, he's working on his fern. There we go. Fern. Okay, and then we can close a bunch of these. There we go. And we'll go back to Twitch. Beautiful. Back to restream. Make sure that's still loading correctly. Over to here. This is perfect. Amazing. There we go. Okay. So now we need to make our spawner. Spawner's going to be the painful part. No, I lie. The spawner's not going to be the painful part. Setting to do. Generate move positions. Unit events. Enemy factions. Find target in shooting. Health. Bullets. Entity spawning.
Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to dynamically instantiate some entities. We're going to have the soldier spawn the bullet, which will then move towards the enemy and deal some damage. Okay, so in the last lecture, we already created the bullet entity. If I hit on play, the bullet starts moving towards the enemy, hits the enemy and deals some damage. So now let's leave that with the exact same behavior, but spawn it from the soldiers. For that, let's go here onto the shoot attack. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to build a super simple zombie spawner. This is going to be a quick lecture because we have already learned everything we need to do. This is going to be an excellent example about how after you learn how that works, it becomes actually relatively simple to build brand new systems. Okay, so far here we have our soldiers, we have zombies, I can approach the soldier, and yep, there you go, starts attacking the zombie and eventually kills the zombie. So all of it is working perfectly. We've got the soldiers, we've got bullet spawning, everything works. So now that we have the bullet spawning working, let's also spawn some enemies as well. Like I said, the logic is going to be very similar to what we already did, so this is going to be an easy lecture. First, let's begin by making our authoring component to store some data. So new mod behavior script called the zombie spawner authoring. Then over here, let's write our normal code. So we have our zombie.
Okay, so I'm 80% sure that I've already got that, right? No, I do not. Oh, no, I do. Yeah, it's right here. I'm just going to close that one.
Spawner is going to be I component data, and then let's make the standard baker class. So baker, let's bake zombie spawner authoring, so not the zombie. Okay, this one, and over here, same thing as always, entity, get entity. Let's get a dynamic entity and add component onto this entity, a new zombie spawner. Okay, great. So now let's think, okay.
Usage flag get dynamic. Did I do that? Oh, yeah, I did. Okay. Do pedestrian spawner.
What data do we need over here? The goal is to spawn a zombie and spawn a zombie every certain amount of time. So let's store a float for a timer, another one for a timer max. And on the baker, on the authoring class, over here, let's expose the timer max. And when constructing the zombie spawner, let's set that one. So timer max, authoring. Timer max. Okay, just like this, let's save. And over here, let's make an entity. So inside the entity subscene, create a new empty game object for the zombie spawner. And over here in the world, let's place it over there on that corner. Okay, great. Then let's attach a component. So let's put the inspector back into authoring mode, add the zombie spawner authoring, and let's put the timer at something like 1.5. So we want to spawn one zombie every 1.5 seconds. Okay, that's that. Now let's make the system to run this. So in our systems folder, let's go ahead, create a new entity size system called the zombie spawner system. And now here, let's first get rid of.
Okay, do I have my spawner system? No, I do not. Dots, my system. Spawner system. And we want Beautiful. And we don't need the, actually, I don't think we need the on create.
For these, we just need the on update. So let's
Oh, I was right. We only need the on update. Sweet.
do our on update. And now let's do system API query. And for handling this logic, first we need to have the local transform, so we know where to spawn zombies. Let's do ref ro local transform. Okay. And
Oh, wait, I forgot to do something. This would be literally that. See, that's not how I would want this. I want this to be like, if we're going to do that, I want that there. And then maybe, no, I don't really like that either. Maybe we do this. There. There we go. Does system state have delta time passed in? I don't know. We'd have to check. When you say system state, what, like, is that an entity thing that I haven't looked at yet? Oh, yeah. Give me a sec. Here we go. I have a feeling that it wouldn't have delta time because it wouldn't make sense for it to have delta time. It does. Oh, okay. So it has it, but not for long. So I think a bunch of these are probably being left out because they want you to do it a different way.
then we're going to need our refrw for the zombie spawner. Okay, that should do it. So let's put this inside a for each our refro local transform, call it local transform, and then refrw for the zombie spawner, call it zombie spawner. Okay, like this, let's just format everything, refro, refrw. Okay, yep, here's our query. Now first let's do the usual thing, so count on the timer and reset. So let's go inside the zombie spawner, grab the value rw, and grab the timer, count it down by system API.time.time, and then let's check the zombie spawner value, let's just read the timer, and if the timer is above 0, if so, then the timer is not yet elapsed, so let's skip it, let's continue. But if not, then let's run this code, go into the value rw, and reset the timer, so set the timer back into the zombie spawner, let's read the timer max. Okay, so this handles the timer logic, and then over here we just want to spawn our zombie. So for doing this, it's pretty simple, we're just going to do the exact same thing we did for the bullet. So in order to get the reference, let's go here onto the entities references author.
What was... We're just gonna... Do we care about an interval? Not really. Spawn them as quickly as possible until you hit the cap.
Authoring, and let's add another field. This is going to be for the zombie prefab entity, and then up here for the zombie prefab game object, and then let's paste both of them. So the zombie pass in this reference as that one. Okay, great. So now back in the spawner system, over here we can grab that one. So the entities references, let's grab it, system API, get the singleton of type entities references. With this we have our component, and then from this one inside we can simply grab the zombie prefab entity. So for this we can spawn it. So let's go through the state.entity manager. Let's instantiate the zombie prefab entity. This will be an entity zombie entity. The spawn zombie, and let's just position it. So system API, let's set the component on this zombie entity, and the component, let's go inside the local transform, inside the type itself, and let's use from position and pass in this local transform, read the value for the position. Okay, yep, that's really it. This
So that's the entity reference. Entity's reference, which is, wait. Here's the entity to do. Get singleton entity references. Okay, so we need to go to the it's probably in here. Oh wait, no, that's not it. Events, enemy factions. It's probably in here, right?
Make the usual singleton logic, so public static of type game assets, call it instance. Let's make with a public get and a private set. And then on the private void awake, we just set the instance equals this. Okay, there's our static singleton instance. And now the reason why I said it doesn't need to be a singleton right now is because we're going to make the units layer a constant, and constants do not require an instance. But still, this way this class is nicely prepared for the future. So here, let's define a public const int for the units layer. In this case, we have unit layer 6. Okay, great. So now we have some data here. So back first over here on the unit selection manager, over here, let's refactor this code. Instead of using this local variable, instead of that, let's go inside the game assets and access the units layer. Yep. So now we can copy this code, go into the find target system, and on this one, let's define the collision filter like this. And we do use the game assets.units layer. So in case we want to modify the layer, we really just need to go into this class and modify this, and everything else will work. Okay, so let's uncomment this, and we can now include the collision filter on the last one on this one. Okay, that should do it. So now this will return true if it finds anything, and if it finds anything, if it finds at least one entity. If so, then the results will be populated in this list. So let's check if it is true. That means there is something within this area, and if so, then we basically just need to validate these entities. Again, keep in mind how here we are looking at each of the component. Let's save everything. Make sure to save all the files, which by the way, the shortcut is Control-Shift-S, and it saves all of them. Okay, great. So here, let's wait for it to compile, and we need to set up some components. So let's go into our base unit, and on this one, let's roll down, and this one just needs to have the component. Okay, great. Now let's select the soldier unit. On this one, for the find target components, let's find targets within a range of some like this, save both files. And now we just need to assign the timer max. So over here, let's select the base unit, scroll down to the find target, and for the timer max over here, let's put it on 3F, meaning it is only going to look for targets once every 3 seconds. So yep, let's play and see the logs. Okay, there it is, and right away they found. Let's first count on timer. So the usual thing that we just did a while ago. So let's grab the timer minus equals. Let's go system API.time.time. And then if the shoot attack, let's read it. Let's read the timer. If the timer is still above 0, then not elapsed.
Wait. Actually, where was it? Unity dots tutorial. Is it this one? Yeah, it's this one. this has a spawner. Spawn something with random colors. Do config authoring. Yeah, sure, but I don't know if I care about having that, right? But this is what I'm thinking of here. System API get singleton config. And the config is this config here. But what's telling this that this is a singleton? Nothing. We can have multiples of these. Whatever. My United States, whatever. State enabled false. Get singleton config. Random. There we go. Yeah. Config tank prefab. So that comes to here, which is tank prefab here. Can I do the pedestrian prefabs? Yeah. 100%. I don't like it. I'm just going to put that out there. I'm not a fan of doing that. This is a very heavy object right here, right? Which creates a problem, a potential problem, where we're going to bust the cache constantly because of how big this is going to be. But it also might not be a problem because we'll stop as soon as we hit a certain number. And I think there's a way for us to query for the on update, like the on update to only fire when when we're below a certain amount. With the with statement stuff thing. So then we won't hit it. Well, there's the so on the on start, right? They have we come down here, right? They have this. Required for update. This tells this that hey, if we don't have one of these, we don't have a config, don't run the update. So that tells me that there's probably more that we can do with this, right? So if we say pedestrian spawner, entity manager. There is probably a way to check whether or not what the value of the pedestrian count is, right? So if the pedestrian count's too high, don't run, right? But I think the real thing is Unity entity manager. What was it called again? So on create we do state dot entity manager. Unity entity manager. This is probably what we want. Entity manager is an API that provides utility methods to create, read, update, and destroy the entities within your project. Each world has an entity manager that you can use to manage all the entities within that world where possible. It is best practice to use the methods in System API to access entity data in the world over Entity Manager. However, Entity Manager is useful to manage structural changes on the main thread. Some operations available to the Entity Manager API cause structural changes to happen. To create structural changes, Entity Manager waits for all running jobs to complete, which creates a sync point. The sync point blocks the main thread and prevents your application from taking advantage of all the CPU cores, which might cause performance issues with your application. That's true. As an alternative, you can use entity command buffer to queue up structural changes so that they happen only at one point. However, ECBs have their own performance considerations. The main difference between using Entity Manager and ECB to manage the entities in your project are as follows. If you want to perform structural changes initially on the main thread, use Entity Manager. This is more efficient than using ECBs to do so. You can't use Entity Manager in jobs, so it's incompatible with the job types like iJob chunk and iJob entity. You can use the ECB in jobs to queue reference structural changes, but you must then execute the structural changes on the main thread after the job is finished for more information to do. Okay, so that's, we don't want that right now. We're not there. Oh yeah, we're not reorganizing. I don't think we're there yet. Understand what blob assets are. Blob asset concept. Anyways. This is effectively what we want. Yeah, this is actually what we want. So we have the tank prefab. We don't care about the cannonball, but we do care about the count. And we have that there. Random color. Yeah, so like if we pass the array, the problem with passing the array is that the second that you pass the array, that goes into your cache, right? And then the entire array has to sit in your cache for every time that it operates anything, which is bad. So we want to make sure that we do it without that first, right? Like I need to be able to make sure that whatever I'm doing does it without. But it looks like this is probably what we want anyways. Right? So if we were to take a look at this, this is probably fine. Yeah, this looks like probably what we want right here. Right? So we're going to delete this because we don't care. And then we're going to do this. And then we're going to do the get singleton. I guess like we do this and it's pedestrian spawner, right? But there's nothing distinguishing this as a singleton and it's bothering me. Like this is exactly what we've got, right? And it's not distinguished as a singleton anywhere. So like what's the issue here? Wait, what? Do there's our authoring. Authoring transform flag none. I guess for now we can actually we could just do this as a game object instead of a game object list, right? Oh wait. Public game object prefab. And then authoring dot pedestrian prefabs. You have to spawn the tanks. Wait, okay, so what's the issue here? We do this real quick. So why is this being the issue? Config. We got config authoring, and there's the config right there, and it's an iComponent data, pedestrian spawner. Oh, this needs to be an int. We could forego this for now and see if that fixes it, but I don't think it will.
Question. And on instead of defining a local after we don't damage. So this is going to be the bound entity, and yep, this is exactly the one that we want to destroy. Okay, so that's towards it. Move there, just make sure it should be nice and workable. So we do a query for local transform bullet and target, which yep, our bullet has all of these. Then we grab the target position, calculate the move direction towards it, move the bullet towards the target, then check the distance squared. If it is close enough, but as you can see, again, constantly jumps back and forth. It never actually gets close enough in order to hit and destroy itself. So this is a problem with very fast moving projectiles. Now, the solution to this is basically we need to test to make sure the bullet is not overshooting the target. Now, there's one very simple way to test for that. As the bullet gets closer to the enemy, we can just compare the distance towards the target. We compare the distance towards the target compared before the distance point. If the distance after the instantiate object in the we already created the bullet entity. If I hit on play, the bullet starts moving towards the enemy, hits the enemy and deals some damage. So now let's leave that with the exact same behavior, but spawn it from the soldiers. For that, let's go here onto the shoot attack system. And here, instead of dealing damage instantly, instead of that, we want to spawn a bullet. Now, spawning an entity is actually then we get the entity that we can use over here. In the editor, I would simply drag the prefab reference, but systems in ECS, they do not have any game object in the world, so there's really nothing for us to drag a direct reference. And of course, there's also the fact that we have to go through the bake process. Here, we are not instantiating a game object, but rather an entity. So we need to take the vulnerable prefab, bake it into an entity, and then we get the entity that we can use over here. So one solution is to make a component that takes a game object field and converts it into an entity. And we could do exactly that, make a specific component just to store the vulnerable prefab. But as we're going to be making this entire game, eventually we're going to need to reference various object prefabs that we're going to spawn, like the soldiers, the zombies, the bolts, and so on. So instead of just one specific component for each object type we want to spawn, instead of that, let's create a component to store a bunch of entities reference. So let's build that in the authoring. Let's right click, create a new model behavior script. Let's call it entities references authoring. Okay, let's just clear our error over here. And let's just comment out this code, just make sure the code compiles. Okay, let it compile so we have our components. And on the entity subscene, let's construct an empty game object, call it entities references. And I like to put it up here, so let's just drag it up to the top of the hierarchy. And now let's attach the entities references authoring. Okay, so now let's open this. Over here, let's write the normal stuff. So a struct entities references implement I component data, and then make the baker. So class for the baker of entities references authoring.
Okay, wait. Let's go back.
Just make sure the code compiles. Okay, let it compile so we have our component for each object type we want to spawn. Instead of that, let's create a component to store a bunch of entities references. So let's build that in the authoring. Let's right click, create a new model behavior script. Let's call it entities references authoring. Okay, let's just
Okay, so we're just gonna come down here and we're just gonna delete this. We're gonna come up here, we're just gonna delete this. This is fine. Don't mind me. Beautiful. It's fine. To do right. We want project. We're going to come into the entities authoring. We're going to create a new mono behavior. The reference authoring.
just clear our error over here and let's just comment out this code, just make sure the code compiles. Okay, let it compile so we have our components. And on the entity subscene, let's construct an empty game object, call it entities references. And I like to put it up here, so let's just drag it up to the top of the hierarchy. And now let's attach the entities references authoring. Okay, so now let's
game object, create empty. T reference. We're just going to go like this. Do away with all of our errors. There we go. And we're going to do this and add that. This be save and reload domain. Project settings. What was it? It was editor? Reload domain, reload scene. I can't figure out if this is coming back. I'm not sure if this is coming back or not, and it looks like it is. What the where is this coming from? The problem is that there's no compile errors. Like, I can compile this and there's no errors. So the error exists somewhere in the editor itself. The question is, what's causing this error? Because it doesn't say. If I remove the pedestrian spawner and this, do we still get the error? I gotta say, some of these errors are just fucking terrible. They give you nothing. Like literally nothing. It's like, hey, you got an error, but where it is, we don't even know. Enough information to get to the error? I think you're asking too much, boys. Scene transform values are not applied to scene child transforms. But oh, if I clear. Save. I don't like using Chat GPT for that stuff. Clear all caches. Try clearing the cache. Close the project, delete the libraries folder. You can try that. That's actually the most promising one. Data, local projects, Unity, Trucktoon. They said delete the libraries. Okay, we're gonna close this for now. And they say delete libraries. And I guess objects too, right? Well, it's fine. We fuck it up, we fuck it up. No, I think it will regenerate it, to be honest. I don't think it regenerated it. Yeah, maybe when I start the editor. How's your day going, Chrono? It's going okay. That's good. Look at that. It did regenerate the. I'm I'm assuming that it has something to do with something that I did with the spawning. I think it's this prefab here. Excuse me. Reference authoring. There. It's the game object. Yeah. 89% sure here. But eventually this is going to finish running. I know this makes it slower, but if it saves me from okay, we can clear that. Okay, so now if I go to projects, scenes, I think it's just testing scene, right? There we go. So it was 100% that was the problem. So if we come back to here, we can see
let's open this over here and let's write the normal stuff. So a struct, entities, references, implement I component data, and then make the baker. So class for the baker of entities, references authoring. Then let's implement the abstract class. Let's get the entity, get it as dynamic. Then add component on this entity, new entities references. Okay, great, just like this. Now with this over here on the entities component, let's add an entity field. So public entity, let's call it bullet prefab entity. Yep. And now up here on the
okay. So here, instead of this being this, we do entity. And then here we do entity. And then we just want this. Okay, so now the problem is that entity is not like this here needs to be a not a there's a special kind of list for this effectively, right? So if we go here, there we go. Pedestrian prefab. And then we do prefabs.0. It wasn't all in my head. No. I knew it was something. I just didn't know what the fuck it was. Okay, so this allows us to have this, right? So if we do get delta time. Okay, right now we only have one anyways, right? We only have one that we want to spawn anyways. But this one actually is a problem that we're gonna have to fix at some point. Right? So like if I move her into here, I think we get a warning, right? Do we get a warning? Oh, we don't. Sweet. This needs to be a rigid body. Oops. No worries. There. The slow march down. Give me 1 sec. I'll be right back. All right, I'm back. Sorry. Okay, we're slowly getting places here. Okay, so this also needs a collider, right? Capsule collider. It's not what I wanted. We go up in the Y there, and then in the height we give it a bit more, and then we can come down right about there. Beautiful. There we go. Maybe up just a bit more. Do that. There we go. And we can bring in the radius a bit more. Save. Take it out of orthographic view. Hit enter. It's beautiful. Do we get can we drive? No, we can't. Driving still requires to reload the scene. No, driving just doesn't work. Wait, what? Driving stopped working. Even on what if we do domain reload? Reload scene. Stop. Domain reload. Reload current scene. I think you're right. There. Oh, there we go. Sweet. Progress. Okay, stop. I feel like here we should probably do a raycast to find out, like, are we on the ground? But we'll deal with that later. Okay, so we want to switch out the boxes for this, but that's fine. Okay, so then if we load this and we go to the, we don't have the one that we want here. Right, we need a pedestrian spawner. There's the pedestrian spawner right here. What? Is that? Yeah, but it's not showing up. Let's reload current scene. We see that, but we don't see this one. What?
The operating component, let's set a public of type game object, and this is going to be our bullet prefab game object. Okay, and now we do what
Oh, okay. This one's a game object.
we've already seen. So down here on the entities reference, let's set that one equals get the entity of the operating component dot bullet prefab game object with dynamic.
Okay. So then this is another get entity. Authoring bullet game object. And then transform dynamic, maybe?
Okay, yep, just like this. Let's say, now here in the editor, let's just drag our reference. So we've got the bullet, which actually means we need to make.
Okay, so now we can build this. We open this. Now we have it. And we can say, one second.
Make it into a prefab, so let's drag it onto the prefabs. And on the bullet itself, let's get rid of the one over there. And on the entities reference, let's drag the bullet prefab. Okay, so far so good. Now back here on the issue attack system, so
Wait.
prefabs. And on the bullet itself, let's get rid of the one over there. And on the entities reference, let's drag the bullet prefab. Okay, so far so good. Now back here. Prefabs, so let's drag it onto the prefabs. And on the bullet itself, let's get rid of the one over there. And on.
Okay, so then we would do this. Here's our test pedestrian, right? We go to our prefabs, AI. We drag this pedestrian into here. We save. And then we can delete this. This one here. Delete it. Then we go to the pedestrian spawner and we can just drop that into there and hit save. Oh, it's beautiful.
On the entities reference, let's drag the bullet prefab. Okay, so far so good. Now back here on the issue attack system, so we've got the code for calling instantiate. And over here, we just need to reference that entity. So here's another important question, which is how exactly do we get that component? Now we can't really add it here. This is a query that is cycling through the units, and the units do not
Okay, so now we can go. Wait.
have the entities references component. So we can't just add it over here on the query. But the goal that we did with this entities references, this is basically just a single component that exists on a single entity that in itself is going to contain all the references that we need. So since there's just a single one, that means this one is going to be a singleton. And like we saw previously, System API has a really useful function called get singleton. So with this, we can very easily get it. So let's get the entities references. Let's get it just like this. Entities references, entities reference equals down. Okay, so with this, we can easily get.
Yeah. Okay, so now what we would do is inside of inside of our execute? No, it's on update. Inside of this on update here. Right? We use the system API get singleton. API dot get singleton. And this is going to be a T referencing off reference. So give me a second here. We're just going to move that over to here, and we can go like this, and then we can go like this, and then we can go like this, and this, and then. There. And then here we have the baker. Public class baker. Baker here, which is entity reference authoring. There, and then this needs to be public override bake there, and then we're going to take this and copy it and drop it there, and then here we're going to have objects. There we go, and then this will just get the first one, and we don't need that. There we go. Yeah. It's a weak singleton because it can be more than one. And it's just like, I don't know if I like that. You could technically have more than one of them. But it's saying it's a singleton, but it's not really a singleton. Then here we do the entity reference. And this would be T's reference. Is that what he called it? Yeah, entities references. We're going to change the name. Rename. There we go. Unity dots collections. Native array, that's what it is. I think. This returns an entity, right? So this would be a native array of entities. There, and then we would just and then we would do this, and this would be pedestrian entity, pedestrian entities. Prefabs. Well, because like the thing is that it's a singleton so much as he dragged only one of them into the thing, right? Right? So like it's technically a singleton. Yeah. But like singletons exist outside of OOP. Singletons exist inside of the concept of non-OOP languages as well. Like you can have a singleton in you can kind of have a singleton in a functional language, but it's more like it's just globally set. So like it's a variable that can't change. It's all in like, yeah. So like if we were in like C, right? This would theoretically also be like if I had like a sure public static int my stuff equals 100, right? Then like like as long as this is a like a static const of some kind, right? This is kind of what a singleton is anyways. So like the concept still holds. You just might reference it differently. But you could call like, yeah, a global object. That's all it really is. That's all a singleton really is just a way to make a class a global object and validate that it never changes. And even if you try and initiate a new one, it never changes. But like if you're in a language where you don't really have classes and you can just set it as a static like a static hash map or whatever, right? Or struct, then it doesn't really matter, right? So like in C, it would just be like a static struct object, right? Of some kind. Yeah. The same idea, just different way of getting there. Of course, some of it's going to be more error prone, right? Because theoretically, you could create a new one that's a second instance of it that's held in memory somewhere. Yeah. Okay, wait. Build. Come to here. Huh, we still only have one. I thought we changed it to a native. No, it's a list of objects. Oh, wait. Yeah, that's not what it is. Pedestrian spawner. We want authoring. Entities reference. There we go. And then we grab the prefab AI here and put that there. And then we save. Now we come back to here and we do the pedestrian spawner. And this is fine. But this doesn't need to be. No, this shouldn't be set at all. There. Because this is like at runtime we're gonna grab it, right? This will have its own things. Actually, no, this shouldn't have its own things like that. This should just be the thing, right? Because like, yeah, sure, like having this is kind of interesting, but like it's kind of not, because like at the end of the day, I still kind of need it here anyways. Like these are very tightly coupled. And it's not a matter of just needing like, yeah, no, this data should live with this. Yeah, I feel like this data should live with this. That way we can have multiples of these and they can all hold different types of objects. Wait. There we go. Console, clear, reload domain. And then we're going to reload the scene. Okay, we still have this problem here, native list. Huh. It worked here, didn't work, doesn't want to work here. Why is that? Splittable component in contains a potential nested pointer field. Serializing bare pointers will likely we did this exactly the same way, didn't we? I feel like we did. Now I just feel crazy. Okay, so these are the same effectively. This one causes no error. This one causes lots of error. Oh, wait, you know what? This is actually the problem. Probably. I feel like this is the problem. Because it's getting confused to which one it is. Hmm. I wonder if it's this. A little bit. Please try re-importing. Would just be a refresh? No, that wasn't it either. If for whatever reason the pointers field should in fact be serialized, then add a chunk serializer. But I don't want that. I feel like this is the problem. I don't think this is. I do feel like this is actually the problem here. We're going to try deleting that and see what happens. Okay, what we're going to do is we're going to clear this and we're going to reload. See what happens. Previous scheduled job entity. Wow, it really doesn't like that. It is 100% the prefab. Like actually the prefab. Sorry, not the prefab. I don't think it's the prefab. No, it's not. Prefab doesn't actually have anything on it. I don't think at all, does it? Yeah, it doesn't have anything on it at all. It's not even going to move. But that's a good call. Good call. It's probably this, if I'm being honest. Okay, so what we fuck. We need to do is we do this. We bring that back. We go here. Then we come back on this. Here, one sec. There we go. Then this goes away. And this goes away. That's fine. And then when we come back into here after we're done, there, and then we have this, we move that into there and we hit save because I keep forgetting to do that. We go to projects, authoring, and drop that in there, console, and we see the error. Okay. This is a problem because I think I know what's going on here. Yeah. we need to always have at least one, right? Can't be empty. Do. Workers here initial. I thought I did. I fucking hate this shit so much. This is actually driving me batty. Why is this so bad? Like the workflow for this is actually horrible. It's like did you make sure to save every single time you touch something? Maybe you can just add a save before reloading in the editor script. Yeah, I could probably do that. But like, I don't think that I should have to. I'm gonna do it, but still. What it is that like I'm constantly in a state where like even when I control save, like even when I control S after like everything, but I literally have to save. If I alter even one thing, I have to save. And if I don't save, I will lose state. I'm in a constant state of like everything is ephemeral. The entire project is ephemeral, so you have to save after every change. Right? You rename something, save. Everything has to be saved all the time. I don't know. There doesn't seem to be, and it's because of dots, like solely because of dots, and it's pissing me off. But then we also get these horrible errors that don't tell us anything. 21. This is what 21. Reference authoring 21. We're gonna have to figure out the list better. I will deal with that later. So, okay, so now we can do potentially this because we don't actually want we want to have these together, right? Now I want to remove that, and then I want to come here and save. Okay, and then we go to back to console and we hit play and we make sure that we don't have errors. Beautiful. Progress. Progress is being made slowly.
Get it, and then down here on the instantiate, let's go inside and grab the bullet prefab empty. All right, awesome. So this is going to spawn our
Okay, so now what we want to do is we want to go to the pedestrian spawner here. We want to add the random move authoring, and we'll say 5. Oh no, 4. And then we'll go back to here and we'll look at the cube quickly. To do random move authoring. Perfect. Okay. Sweet. Welcome back. Okay, now we just want to do this here. Okay, so I'm going to move this off screen so I can look at it while I do this. Here, there we go. Here's this pedestrian spawner, and then we've got the pedestrian mover here. And this, and then this won't be an entity references. This will be a pedestrian spawner. There. For each ref RW, pedestrian.
bullet prefab. Let's just define entity for the bullet entity. Okay. Now what we need to do is actually initialize it. Hello and welcome. I'm your code monkey. Entity, get entity. Let's get a dynamic entity and add component onto this entity, a new zombie spawner. Okay, great. So now let's think, okay, what data do we need over here? The goal is to spawn a zombie and spawn a zombie every certain amount of time. So let's store a float for a timer, another one for a timer max. And on the baker, on the authoring class, over here, let's expose the timer max. And when constructing the zombie spawner, let's set down. So timer max, authoring.timer max. Okay, just like this, let's save. And over here, let's make an entity. So inside the entity subscene, create a new empty game object for the zombie spawner. And over here in the world, let's place it over there on that corner. Okay, great. Then let's attach a component. So let's put the inspector back into authoring mode, add the zombie spawner authoring, and let's put the timer at something like 1.5. So we want to spawn one zombie every 1.5 seconds. Okay, that's that. Now let's make the system to run this. So in our systems folder, let's go ahead, create a new entity system called the zombie spawner system. Now here, let's first get rid of these. We just need the on update. So let's do our on update. And now let's do system API query. And for handling this logic, first we need to have the local transform so we know where to spawn zombies. Let's do ref ro local transform. Okay. And then we're going to need our ref rw for the zombie spawner. Okay, that should do it. So let's put this inside a for each. For each our ref ro local transform, call it local transform, and then ref rw for the zombie spawner, call it zombie spawner. Okay, like this, let's just format everything. Ref ro, ref rw. Okay, yep, here's our query. Now first let's do the usual thing. So count on the timer and reset. So let's go inside the zombie spawner, grab the value rw, and grab the timer, count it down by system API.time.time. And then let's check the zombie spawner value. Let's just read the timer. And if the timer is above 0, if so, then the timer is not yet on the left, so let's skip it. Let's continue. But if not, then let's run this code, go into the value rw and reset the timer. So set the timer back into the zombie spawner. Let's read the timer max. Okay, so this handles the time logic. And then over here we just want to spawn our zombie. So for doing this, it's pretty simple. We're just going to do the exact same thing we did for the bullet. So in order to get the reference, let's go up here onto the entities references authoring, and let's add another field. This is going to be for the zombie prefab entity, and then up here for the zombie prefab game object, and then let's paste both of them. So the zombie in this reference as that one. Okay, great. So now back in the spawner system, over here we can grab that one. So the entities references, let's grab it, the system API, get the singleton of type entities references with this.
Okay.
So now back in the spawner system, over here we can grab that one. So the entities references, let's grab it, the system API, get the singleton of type entities references. With this we have our component, and then from this one, inside we can simply grab the zombie prefab entity. So for this we can spawn it. So let's go through the state.entity manager, let's instantiate the zombie prefab entity. This one.
Oh, I see what he's doing. That makes sense. That actually makes a lot more sense now. So then this would not do this at all. Yeah. This would just be that. Yeah. Okay. Okay. Okay, it makes sense. I see where he's going here, and it does make actual sense here. Then this would be a entities references there.
This will be an empty zombie entity. Despawn zombie.
Here we go. Okay, so get singleton, yes, and then local transform. Why is my local transform not working? Oh, there we go. And then we've got count pedestrian reference. One sec. Local transform. Yeah. Pedestrian spawner. We're going to move those. There. That's fine. Okay. And I think for now we don't actually care too much about that, so we'll do that. Why are we going to move speed? To do zombie spawner dot. Oh, sorry, not zombie spawner. Pedestrian spawner dot value dot read write dot max pedestrians. Value read only. Read write. Oh, wait. Value read write. Pedestrian. +1. That's fine. But we want to entity pedestrian entity state dot entity mat entity manager dot initiate the prefab. Yeah. Okay. And then after that, if pedestrian spawner is not equal to null, because what does this return? I'm a little confused. A C# question. Would this always return a valid entity? Like, do I have to check whether or not this is valid? Is valid? I guess maybe. I don't know.
and let's just position it. So system API, let's set the component on this zombie entity, and the component, let's go inside the local transform, inside the type itself, and let's use from position, and pass in this local transform read value for the position. Okay, yep, that's really it. This should be working. As you can see, super.
Oh. There. And this should work. It's not going to be burst compiled, but that's fine for now. Okay, so it is possible if pedestrian spawner dot is valid. If not pedestrian, if what we're going to do is, because it's usually going to be valid, we're going to do that, and then we can do a return. And then here we would do debug dot error. Something went horribly wrong. Does not. Oh. Okay, I'm just gonna not worry about it, and it's going to just throw an error if it happens to let me know. In the weird happenstance that it does happen, we're gonna have a problem. So then we can do this, and we can add a component, and this will be a reference authoring, and then here we're going to do project this, save, go to console, clear, save, reload current scene. And we're going to do this. Save, come back to the pedestrian authoring. Oh, that's why. I bet that was actually causing problems. I forgot to check where this was. No, this. That's way the fuck over there, and we want to move it. I think this should spawn things, and it does not. It's spawning nothing. Why is it not spawning anything?
For example, all the exact same logic that we already did. So let's save both files. And here in the editor, let's just make sure to drag the zombie prefab reference. So that one, and yep, let's test. Okay, here we are. And yep, right away, we do see one zombie spawning, another one spawning, and another one. So yep, that's it. Make sure to read the value for the position. Okay, yep, that's really it. This should be working. As you can see, so
Is this not working at all? Oh, wait a second. Paul, thanks for the follow. Much appreciated. Sorry I butchered your name. I know exactly what I did wrong. No, wait, there's 1,000 of them. Never mind. Okay. We build. We go back to here. We hit play, and we should fill up really quickly. I want all the fills. Just spam my logs. There's nothing in the logs. Well, I think we found the problem. Pedestrian spawner. Yeah. There's the entity reference.
super simple, all the exact same logic that we already did. So let's save both files. And here in the editor, let's just make sure to drag the zombie prefab reference. So that one, and yep, let's test. Okay, here we are. And yep, right away, we do see one zombie spawning, another one spawning, and another one. So yep, that's it. Everything is working. So our zombies are spawning, our soldiers are shooting them, and everything is working perfectly. So yep, this lecture is actually an excellent example about how, after learning how DOS works, you can build new things rather quickly. RefRW. Okay, yep, here's our query. Now first, skip it. Let's continue. Logic for both of them. So the zombie has going to develop RW and reset the timer. Great. So now back to our component. Let's instantiate the zombie and the component. Yep, that's really it. This should be working. Yep, let's test. Okay, here we are. And yep, right away, we do see one zombie spawn.
Sorry for the delayed response. I was on an ad break. Oh, sorry about that. Thank you for the follow. Much appreciated. Ad breaks suck. I hate ad breaks so much. Okay, so my code looks fine. For the spawner, at least. Right? But it's not running. Let's see here. For each local transform, pedestrian spawner. Pedestrian spawner. Pedestrian spawner. It's right there. Max 1,000. Okay. Let's go back to my pedestrian spawner. There's my pedestrian spawner. There's our max. 1,000 is the default. So why is this happening? Oh, you know what? I bet it's this this here. Let's see if we get lots of them. We should see them all over the place. Maybe, hopefully. Ah, there we go. Do you think we have enough of them yet? Is there a way to see performance? What's the command to like see the performance thing up in the corner right here? Unity, view, show performance. To open this window, click Stats button on the top right corner of the game view. What? Stats? Unity 6, show stat window. Oh, wait. Oh yeah, it's because it's not there anymore. Oh, stat. There we go. How do I build? I guess that's the next thing that I need to do. Do. Oh, right, I need to reload scene. Oh, we're dropping FPS here. We're dropping it. We're dropping it fast now. Do. Oh wait, that's not what I wanted. Where's the spawner? No, I want my spawner. Actually, I guess here we have an idea of how many we've got, right? We're down to 30. We're at a good 35 before we start actually like taking a hit. Yeah, it looks that way. Let's take a look at performance computer wise. Performance. We're definitely getting a lot on one of the CPUs. Yeah, like all the CPUs are starting to get up into the get up there pretty high. Where's the try count? Here, this is definitely the problem. So like if I drive away from this, does our FPS go back up? No, we're still drawing like 4 million tries. So in this situation, it's the tries. I guarantee you it's the tries and not the not the maths. So we've got 7 million, but like our FPS isn't dropping dramatically. It's kind of hovering. Right? But our tries aren't really going up too fast. So now the question is, how do I bake this? How do I build this? What was it? You said that you we got a lot. File, build profile. Intel 64-bit. Open scene list. Add open scene. Oh, we have to add each individual scene by hand like this? Interesting. I don't like that. Okay. And you can build or build and run. Is this all I need to do? Do I need any of this? This is all good? I don't need the PDB files or anything like that. We'll leave it. We'll leave it. Let's do build and run. And then we just allocate where we want our builds to go. New folder. Builds. Select folder. You know why I want to do this build and run, right? No, it has nothing to do with performance. I want to make sure my vehicle will drive. Oh, look at this. Is it still building or did it fail? Why am I in test scene? Oh, I'm supposed to be in test scene. Interesting. Well, the better gizmos is an error. You're missing assembly references. I'm guessing that's the PDB? Maybe? We still get the same failure. Yeah, let's try. We cleared it. Let's clear. Projects. Let's go to scenes. Test scene. Hey, it broke my project. Yay! So good. Okay. Interesting. All right, let's try doing a build again. Okay, so let's fix this. Oh, interesting. Your files are probably not in an editor folder. Better gizmos. Downsized display does not exist. Oh, that's weird. Okay. Why don't we do this and just reinstall, re-import? Yeah, I was missing an import probably. There we go. All right. So we got our scene back, and let's make sure that it works. We're gonna reload open scene. We're gonna hit play. We're gonna make sure that we actually spawn and we can drive around still. Okay, sweet. Okay, so that works. There we go. Now, if I do build, hopefully we don't get any problems. The type or namespace. Downsized display. Oh, you know what? I think I know what it is. Hmm. Only use in editor. No, that's the draw on selected, so that shouldn't be a problem. That's not even being used. Yeah. Build. Build. I think I'm just removing better gizmos. I think that's actually what it is. Okay. There, and then we go to Windows Project Manager. Oops. Better gizmos. Remove assets from project. Remove. Build. I'm not saying that my stuff isn't potentially at fault too, but I think better gizmos was the problem. Yeah, better gizmos was definitely the problem. Fuck. It's fine. I'll work it out. I'll probably just work it out later, to be honest. There is a problem with the pedestrian spawner though. The problem is that the pedestrian spawner, all the pedestrians go the same direction. And I think I know why. I think it has to do with with uh I think it has to do with the random numbers and it's not being properly set. So everybody has the same random number. Which is fine for now. Like I don't actually care that much. For right this moment, I don't care that much. We can live with that. There we go. Built with Unity. Oh, this is exactly what I was afraid of. Yeah. I had a feeling that was going to be the problem. Through the input management system. So this happens in the editor as well, right? Where the scene needs to be, you need to reload the current scene before it will work. So I was wondering if that was going to continue happening with this vehicle going forward, right? Like if it would still happen. And it absolutely still happens. Oh, it's on the vehicle controller that's attached to the truck. And then on destruct, we disable it. The interface? Well, if we look at it, right, we have the player and then we have the vehicle controller and the player input. Maybe these need to be ordered differently. Maybe this is the problem. Maybe this should be before the rigid body. Because these happen in series, right? It's worth a shot. The worst case scenario is that it doesn't fix it. Now, if I go back to the scene and we add to the scene, create a cube, and then save and hit play, I don't think I can drive anymore. Oh, I can drive. Maybe that fixed the problem. Let's find out. I don't use the player input, and it's fair. Oh look, made with Unity. Can we drive? We cannot drive. Yeah, driving does not work. Ah. New physics systems right now. Give me a second. Twitch is taking its sweet time loading.
So you may have used the new input system before, and chances are you did so by adding a player input component, use the default input mappings, and you probably use the send messages behavior or invoke Unity events, and then just use this player input component to manage all your input. This probably worked just fine, but it didn't feel quite right just using built-in components for something that could be built yourself. And since you're running low on things to procrastinate with, you want to dive into making a perfectly scalable input system, even though what you already have is just fine for your prototype. That's where I come in. I will give you the satisfaction of learning how to architect a scalable input system in this video. So what I will do is explain a simple diagram to try to visualize how the system is going to work. Then I'll implement an input system based on what I'm talking about, and I'll try to do that as simply as possible while still getting the message across. Okay, first we need to visualize how we should be interacting with the way Unity presents their input system. Let's say this is a PS4 controller and you press the X button on here. Unity takes that, does a bunch of stuff in it that we don't really care about, and it eventually comes into this input map here that we have defined as the game developer. And it ends up determining that, okay, they press the jump button, the input map will fire this on jump event, and then in our scripts that we want to handle input in, we will say, okay, the on jump event was just fired, now what do we do with that input? And we'll get a bunch of information about whatever the input was. So this on jump event will be sent with a context parameter, which gives us all the information about like whether the event was fired because it was just pressed, whether it was because it was canceled, and then if there's certain
I'll show you kind of like the problem though. So I don't think this is a problem with the input system. Just as a heads up, right? Because if I come down here to where's my fixed update again? Yeah, if I come down here, right, and I do, I can do debug.log, and then we can gas input, right? This value here, this will change, but my truck won't move. Right?
value that comes with the input that will be inside of the context, and then we'll have to process that all inside wherever we're actually handling that input. And this is pretty much exactly how that player input component works. It takes the input mapping asset as a serialized variable, and then we can
So let's see. Okay. Okay, let's see if we're gonna move. Okay, we're moving. Yeah. So if we stop. Okay, and then we come down to here and we enable this, and then we come to here, we grab this. Let's duplicate this one more time and we'll move it up. Up and over, right? Like this. Save, and then we'll hit play. Oh, those boxes are supposed to be falling. Are they even falling? Oh no, they're moving. Okay. So now I can't move, but you can see that the gas input's changing. Right? Yeah. I did make my own controller. But like again, the it's just not moving, right? So I'm guessing that it's the vehicle system, right? Because I'm assuming that the vehicle system is incompatible or not fully compatible with the vehicle system. Sorry, not the input system. The physics, the new physics system, I don't know if it's entirely compatible with. Yeah, the Unity physics might not be compatible with the vehicle system, which means that I have to make a vehicle from scratch. But before I make a vehicle from scratch, I should probably see if I can move a regular character. Because a vehicle is going to be a lot of work. Before I do that, though, I will be right back. I'm starting to get very hungry. Yeah. There we go. I'm almost back. No, I am back. Actually, no, I'm almost back. NP, I'm setting up Blu-rays to rip to Plex at the moment. Oh, nice. I had to go ask my girlfriend a question. The answer is what I expected. We got food. Chinese dumplings with a big bowl of chili oil. Oops, wrong camera. There we go.
process that however we want in the controllers that we're building ourselves. Now this is fine, but it's not perfect. It's not giving us that feeling that we're actually being programmers here. Particularly because in every new script that we have to handle input, we have to break down the context parameter, which can actually get pretty complex. And we just have a bunch of boilerplate code in every single script where we're dealing with parsing the context and figuring out exactly what this event means. So instead, what we're going to do to get rid of that feeling is, of course, slap an abstraction in between the input map and the controller scripts where we want to be putting into action what we're getting as input. So this input reader that we're going to make is going to be similar to how the input map already works. It's going to be an asset. We're going to write it as a scriptable object, so we'll be able to create an instance of it within the project folder itself. And what we're essentially going to do is take the events that we're getting from the input map and process the context inside the input reader, so that we're essentially creating our own API based on the requirements of our game, rather than dealing with that individually within each controller script. So in this video, I'm going to do all this stuff from scratch here. I'm going to create the input map from scratch. I'm going to create the controllers from scratch, and then I'm also going to create the input reader and try to convince you why that layer should be there. Now, I will be using interfaces and events in this video, so if those are unfamiliar topics to you, this might be a little bit harder to follow. Now, I still encourage you to watch this anyways, because hopefully I'll be
I'm gonna 100% come back to that.
Automatically appear. This is used by the character.
I had problems with the player input component, so I found that way. Oh yeah, no, it's. I think the gist of what I've gotten from his video so far is that he's not like what he's suggesting is probably a good abstraction, but I'm just not going to worry about it right now. Because like the input system's working. It's just not. It's working. It's getting the values, but it's not actually able to use them. I have a feeling though that the actually, one sec. This box should fall. Yeah, that's what I thought. Mm. Right, so the problem that I'm running into is that we don't have physics outside of uh, sorry, we don't have physics outside of the entity system. Yeah, yeah, okay. Yeah. I'll be right back. Oh yeah, no worries. I just had to take my plate away. Okay, so mm,
All right, guys. Well,
oh yeah, I should probably put my headphones on so I can hear stuff.
welcome back. This time around, we're going to be looking at the former Rivals character controller. Now it is just part of the Unity character controller package now, which is just a character controller for .dots ECS. Now, this is going to be just going through the character controller samples that's here on GitHub. I'm just going to roll through some of these tutorials real quick and just basically try to get something up online relatively quickly. So yeah, we're going to go through some of these tutorials, get the project set up, and get some of these abilities working. All right, so this is just our empty scene here. We just got some blocks to
Open controller package documentation. I need to intake the movie/shows. Was the discs come in, or I'll get backlogged. I have 120 terabytes of media on my server. Holy shit. What type of array are you using for that? Using Unraid? Not familiar with it. Unraid features the ability to easily create storage arrays. Mm. I wonder how it does that. Like how it deals with Unraid NAS functionality. Yeah, but like I wonder how it does the dynamic scaling. because you would get really, really, really lopsided. Like you would have a really lopsided array if it doesn't take care of it well. Do you know how it works? Like in general, like RAID in general, right? For different types of raids, yeah. Like you've got your disks, right? And as they fill up, you want them to be as even as possible, right? So you want them all like this. And then if you add in a new one and you're like that, it's going to be like down here. So you get unevenness. It stripes data on all the drives. Well, that depends on how you're setting it up, right? Because there's depending on your RAID, right? You can have, let's say I have 3 drives, or no, we'll say 4, no 5. This is the max for like the different RAIDs, right? So what we can do is we can have mirrored, right? A mirrored RAID where everything has the same data. All 5 of these all have the exact same data on them. We get maximum read performance and the slowest writes, right? But my data is the most safe and I lose the most amount of data. Then we can have striped, where striped is I have no protection, but each one of these gives me a little bit of data. Like each one of these gets a little bit of data. So I get maximum write and I get the slower reads. Right? But I get no protection. If one drive dies, I lose everything. Then you've got your like so that's RAID 0, RAID 1, right? And then you've got like your RAID RAID, I want to say it's RAID 3 and 5 or 4 and 5 or something like that. I can't remember the numbers. Anyway, so and in those cases, you get like effectively like you get your striping, right? But you get a parity drive, which it sounds like you have a parity drive. You have 2 of them, you said, right? So that'd be I think that's RAID 5 or 6 where you have 2 parity drives. Right? So I get the data from these and I get the striped performance on read and write and stuff like that. And I don't have to, I get a bit of protection, right? So I get the best of both worlds. Then you can do like RAID 10, where you need an equal amount of drives, right? So like this drive. So effectively what happens is you've got these 2 drives, right? And these are striped. And these 2 drives, and these are striped. And then you mirror them. And you can also do the other way around where you mirror 2 drives. And then you mirror another 2 drives. And then you stripe these together. It really depends on your use case. I'm using mine is ZRAID. I think I'm on ZRAID too. Because I use ZFS as my RAID for my NAS. The issue that you're going to run in with ZFS though for you is that you can't add drives to a ZFS array. Unless something's changed in the past like years, you can't really add to a ZFS array. They have ways of doing it, but like you need to store this. So in order to do it properly, you have to. So like they have a system for it growing a Z pool, right? But it lopsides it, and you take a massive hit, and it's really you shouldn't do it, right? So like you can do it. There is a spec and it's in the software that allows you to do it, but you shouldn't, right? So what you want to do is you want to offload all of the data onto another system and then just re-onboard it all effectively. But I'm using FreeNAS. Or no, TrueNAS. They don't make I'm so annoyed they don't make the one the one that I use because I eventually wanted to buy another one and they stopped making it. Yeah, they don't make it anymore and it annoys the fuck out of me. You have to go with the TrueNAS Mini R now if you want to get the same drive count as like what I have. Because I have their XL, and I get it. I think it didn't sell well, and that's probably why. But yeah, I have to go with the server one. 12 drives. It's fucking expensive though. There we go. Beautiful. I don't know if I trust that system. But hey, if it works, it works.
To jump around in and just a regular camera outside of our subscene and then our blocks and whatnot. We don't need this for now, but we'll leave it. All right, so what we're gonna do is I guess first, what we need to do is go into our package manager, make sure you have the character controller installed. It is technically still experimental, but you'll have to install the...
Is it still experimental? Oh, it's not experimental anymore. Character controller. Hey, 48 gigs of RAM. That's a lot of RAM. I don't actually care about that.
the package by name. So you just go to the plus, go down to install package by name, and it is just com.unity.character.
That's right, Rival the Dots character controller is now completely free. Also, Unity is increasing its editor pricing, and the developers of this beautiful colony simulation game made with Unity Dots talk about their development experiences, all that and more coming right at you. All right, so let's just get right into the meat and potatoes of this. So Rival the Dots character controller was an asset that had been sold on the Unity asset store for around $80 or so, and Unity actually just acquired the asset, so that asset is now owned by Unity, and so it is now up on the asset store completely for free. And the good news is they did also retain the developer of the asset, so he is going to continue working on this asset for Unity full time. So really great to see that Unity has recognized the value of this awesome character controller and decided to just scoop it up and continue pumping money into it to continue making this a better to use.
Oh. Wait, is that actually it? I it's not what I wanted. Well, that's not the part that I'm annoyed by. Hmm.
Assets. I did do a video overview of this asset a little while back, so you may want to go check that out for a little refresher on it. But because now that it is free and it's basically a part of Unity now, I definitely am going to start incorporating these in more of my videos. So let me know if there's anything specific that you'd like to see me do with the Rival Character Controller now that it's available to all of us for free. Now, this asset isn't built right into Unity. You still do need to go to the Unity Asset Store and basically add it to your assets, and then from there you can download it through the Unity Package Manager. So I'll leave some links down in the description so you can go to the new Unity Asset Store page for that asset and just add it to your assets. Again, it's completely free to use. Now, the developer of this asset, his name is Philippe. He's no stranger to character controllers because he did also develop the very popular asset, the Kinematic Character Controller. And that asset was not purchased outright by Unity, but because he's now focusing pretty much all his time on the Rival Character Controller, he decided to put out the Kinematic Character Controller for free as well because he's not going to have as much time to provide support on that. So that asset is now available for free. So if you are still using regular Unity without dots or ECS or any of that, the Kinematic Character Controller is now a free and great option for you. So before we get into the topic of Unity increasing its pricing model, let's do take a little bit of a detour while we're still on the topic and just talk about more about some of the Unity assets, specifically the dots ones. So now that the Rival Character Controller has now been purchased by Unity, let's talk a little bit more about some of the other options available to us. Now, one of the other major assets on the Unity Asset Store when it comes to Dots assets was Dots.net, and for a while that kind of was the go-to solution for networking in Dots. However, the developer of this asset has indicated publicly and privately to some people that I know that they aren't really going to be spending many more development resources into improving this project. And actually, it seems like over the past year or so, we've basically just been getting compatibility updates and not really many new feature updates for this. It seems like they've kind of moved on to the next thing after that. So basically, Dots.net is kind of in a state right now where if it does everything that you need it to right now, it still is a viable option. However, just be aware that you probably won't be getting any new features to Dots.net. However, Unity does have a pretty good solution for Dots networking that seems to work pretty well. I experimented with it a little bit, and I feel like it's like one major update from being a very good and viable option. Definitely still is able to get the job done, but there's just some things that are kind of a little bit rough around the edges that I'd like to see polished out before I start making more content around that type of thing. Then some of the other assets include the Orbis Dots Terrain, which is one I did an overview on, and I thought it was pretty okay. Definitely does what you need it to, but it seems like it's very specifically does it in one way. Another interesting one that I have not played around with yet is Flockbox. So this is something that if you're using any type of void simulations, this may be a good option to look into. A fairly new one is this Dots Plus by this developer Lucas, and it's basically a utility library that this person has created while they've been developing out their project. They've created all sorts of helper functions and they packaged it up into this nice little project. Again, not something that I've had the chance to play around with yet, but it does seem like a cool option. And if you do go on that developer's profile, they have created a couple other assets. There's an adaptive split screen one that looks pretty cool if you are creating a local multiplayer type game where you have people kind of split across the world. It kind of does these like really cool different split screens where it breaks the screen up in these cool ways so all the players can see each other and they have a nice view of everything that is important to them in their own.
All right. So the answer is to use this.
Alright guys, welcome back. This time around we're going to be looking at the former Rivals character controller. Now it is just part of the Unity character controller package now. That was just a character controller for Dots ECS.
Okay. Ugh. I'm kind of annoyed. I'm actually a bit annoyed. I just went through this process of getting this set up, and now the answer is you have to change everything. God damn it. Unity, what the fuck?
Character move.
Now, this is going to be just going through the character controller samples that's here on GitHub. I'm just going to roll through some of these tutorials real quick and just basically try to get something up online relatively quickly. So yeah, we're going to go through some of these tutorials, get the project set up, and get some
Yeah, but still.
of these abilities working. All right, so this is just our empty scene here. We just got some blocks to jump around in and just a regular camera outside of our sub scene and then our blocks and whatnot. We don't need this for now, but we'll leave it. All right, so what we're gonna do is I guess first what we need to do is go in through our package manager, make sure you have the character controller installed. It is technically still experimental, but you'll have to install the package by name. So you just go to the plus, go down to install package.character. Have the standard character, third person player, the third person character, drag in for the third person here, folder, character controller, down into the standard characters. We're going for the third person here.
Okay, so if I go in projects, I guess it's packages. Character controller. What was the way to change the way this looks? I want to change this to like that list view one. How the fuck do I do that?
Those ones that we just installed.
Yeah.
And like I said, part of the reason why I told you to wait and then download the exact project files is so you get exactly the same package versions. That way there's no confusion about any differences. If you download the project, you will have over here you see these little three dots. Over here I like to set it as one column layout. Basically this showcases all the project files, all of the engines. So over here on the project files, on the top right corner over here you see these little three dots. Over here I like to set it as one column layout.
Okay. Mm-hmm. That's a lot of comments. Yeah, it was the three dots. It's
here, and under the prefabs, we're just going to drag in the third-person player, the third-person character, and our orbit camera, and we're going to drag these into our subscene. All right, then.
Oh, is that really all it is? Nope, those don't exist anymore. uh. Yeah, they got rid of them all. Oh, that's 10 out of 10. Joy. Yep. This package provides a customizable character controller solution for entities. Yep. Oh, that's so good. Project setup. Importing entities and the physics. Import the two recommended. We'll make sure the domain and the reload scene both disable. This will make entering play mode much faster. I don't care about that. Enable compilation. I think I've got that right. Yeah. We will go through the process of creating a new basic character using the standard characters as a starting point. For this tutorial, we'll be using the third person character. We will first create a basic scene containing rudimentary environment for our character to be in. Create a new scene to add a sub scene, add floor and wall collisions to the sub scene. That's fine. Next, we'll import the third person standard character into the follow the third order to add a character to your sub scene. Okay, so we're going to go like this. We're going to take this player here, and we're going to delete it. I'm going to save. We're going to take, we're going to create an empty object, and we're going to call it dots player. And they want us to take the third person character and the orbital camera. Oh, so the documentation's broken too. Is it maybe just this? I don't think that's it. That doesn't seem right. Standard character. Samples? Is samples really a thing? Do these have to be downloaded? Is that what it is? Okay. Basic AI. Oops. The camera also. Oh my god. Sorry. Why did. Okay, so Unity buys it and then makes it worse. It's like we have the tech. We now have the tech, and the guy who built this, um, he has like all of the details. Like he's set up all of these things, right? These defaults and everything like that. So we're going to go ahead and remove them from the package. This was created in August of 2023, and it's completely this is a completely useless thing now because there's no samples. Like, why? Why would they do that? Ugh.
Hi, and welcome to the first part of our mini-series to create a
Ugh. My level of annoyance is very high right now.
And with the game tab, either over here on the exact same next tab, or over onto the side. So depending on whether I want to see both of them at once, I swap it out one or the other. Okay, so the basics, this is the rough layout that I normally use. Now for a couple more options. So over here on the project files, on the top right corner over here, you see these little three dots. Over here, I like to set it as one column layout. Basically, this showcases all the project files, all of it in this nice compact list tree view. Now if you need to browse lots of visuals in your project files, then you can swap back into the other one. But for most of the time, this compact view works great. Also, since we're Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn how to get the mouse wrong position so we can tell our unit to move there. We're also going to learn about one very important topic, which is deciding what systems should be using dots and which should be normal mod behaviors. Alright, so let's get our mouse wrong position. Now, how to do this is actually quite simple in technical terms.
There's no samples, and all the documentation revolves around the samples that don't exist.
The more interesting part in this case is where do we write this code? Now, when I was first researching and making the prototype for this course, I started by making it a normal I system using dots, and it did work. I had some logic working on a system. I would store the mouse wrong position in a component and read from it from various other systems. Then I added the selection logic on top of it, and again, I got it on working with dots, but the whole process was definitely becoming needlessly confusing and very convoluted. So that's when I remembered how you don't have to build everything using dots. Always remember how you don't have to go 100% dots or 100% game objects. You should mix them and use the right tool for the right job. So the rough general rule that I came up with is actually quite simple. For things that are not performance critical, or simply don't run all the time, or only run on a single object, so things like mouse wrong position, or the unit selection manager, or the resource manager, inventory, and so on, for those, write them as normal mod behavior scripts. And then for things that do require maximum performance, or impact lots of objects, like for example moving units, for that do use dots. So that's the rough guideline that we're going to follow throughout this course. Following that makes things quite a bit simpler and makes it easier to decide when should something be dots or a mod behavior. So that said, let's make our normal mouse position script. We're going to make a normal script, so let's go inside the script folder. Let's actually make another folder for the mono behaviors, and let's right click inside that one, make it a normal mod behavior script, and let's call it the mouse wrong position. Then as always, let's make a normal game object to run it.
All right, time to set up our controller. Create a script. Mono behavior. Dots controller.
So an empty game object with the exact same name. Again, outside the subscene, this is a normal game object. Let's attach the script onto it. Let's reset transform, put everything nice and clean, and open it. Okay, so now here let's do some super simple mouse wrong position logic. Now there are various ways we can do this. We can either use physics or...
Right. I'm actually going to take the vehicle controller, and we are going to take this. Dots controller. Oops. I'm going to drop that in there. Then we're going to do that. Don't need a rigid body. Because it doesn't matter. We're not using it. Then we're going to do the on gas. The on brakes. And we're going to do effectively this. Sorry. Check inputs. Here we go. We're going to take all of this. We're going to dump it in there. And we're going to say float. We're going to change this to gas value. Brake value. And float E brake value. And then we're going to do a float steering. Yeah. These are not super useful right this moment. We might not even use them at all, to be honest. Then we're going to do a debug.log to make sure that we have all of our values. There we go. And then we're going to have a fixed update. And in the fixed update, we're going to do check inputs. And then we're going to come back
We're
here.
not use physics, so let's do the similar approach without physics. First, let's make a function, so make it public so that everything can get this. We're going to return a vector3, and let's call it get position, so this will return the mouse position. Now here, let's begin by constructing a ray from the camera, so we can access camera.main, that's going to be our main camera, and from there we can call the function screen.toRay. This one basically takes in a screen position and converts it onto a ray object, and for the screen position, we can get the mouse screen position by using input.mousePosition. Also, by the way, here, using input.mousePosition, here we are using the input manager instead of the input system. Now if you're seeing some kind of error in the code here, that is
I forgot to do one other thing. The undisable. There we go.
that is probably because you don't have input manager enabled. Although if you downloaded the exact same project files, it should already be set up correctly. But if not, let me just show you. Let me just return something just so this one doesn't throw an error. So just return that. Okay, let's save. So here in the editor, you can go into edit, then go into project settings. Then on the left side, let's go over here onto the player tab. I start off with the construct a brand new plane, and now with this, then suddenly do a raycast against this plane. So let's do inside the plane, do a raycast using our mouse camera ray. Then this is going to return whatever distance we hit. So let's return out, float, and just call it distance. This one is also going to return a boolean whether it hits something. It should always hit something, but let's put it inside if. Then if it hits something, then we can simply go inside the mouse camera ray and we call get point. This one basically returns a position within along this ray axis at a certain distance. So let's screen mouse position. Then we construct a plane directly on 0, 0, 0 pointing upwards. We do a raycast against that plane and we get the position. So this should be working. Let's do a quick test. Up here, let's do an update just for testing. So void update. On update, let's just do a debug.log. To the right, yep, it is increasing on the X and on the Z. And as I move over here, lowering on the X and the Z. So yep, everything does look perfect. All right, great.
Okay, so then we come back into here. We have the dots player. And we're going to do dots controller. Hit save. Hit play. Controller. Yeah, here we can see all of our steering and stuff like that is working. Beautiful. So enjoying Unity.
So here we have one method for doing this. This is just using math, no physics, nothing like that. This is really great and really simple if you have a flat game plane like we're going to have in this game. But for example, if you wanted to use a non-uniform terrain mesh with different heights, if so, then using physics would be a better method. The way you do that is actually quite simple. It's very similar to this. You would go inside physics and do a raycast. This one takes an array as well, so we can use the same mouse camera array. And then we can use this version of the function that just returns a note, raycast hit for the raycast hit. This one also returns a boolean, so if it is true, that means it's going to hit something. And if it is something, then we just return the raycast hit, go inside it next to the point. This is going to be the position where it actually hits. Then if you want, you could also add an external layer mask. So you can use this version with a layer mask and use that to make sure it only hits the terrain collider. And with that, then yep, this would be working exactly the same, but using physics. So depending on what game you're making, you have two options. You can use physics or not use physics.
Back 10 years in time. I know, right? It feels like we're back 10 years in time.
So for that, we can just use the simpler, just math-based method. And yep, that's it. Here we have a nice function that returns our mouse position. Now let's actually use it. Let's get rid of our testing update over here. And now on the input over system, over here, instead of constantly moving to the right, over here we want to move towards the mouse position. So here, let's grab the mouse position. And in order to make it easy to access, let's actually make the mouse position a singleton. So back in this class, let's make the standard thing for making this a singleton. Now since this is an intermediate course, I'm assuming you already know what exactly is a singleton. Basically, it's a super easy way to access a global reference of which there exists only one of them. So here we can just make a public static of the type mouse position. Let's call it instance. Make it a property with a public get and a private set. Then we just implement the normal awake for our
No worries, Chrono.
behavior, and on the wake, set the instance equals this. Okay, that's really it. Now we can easily access this instance, and through there, then we can call this function.
Okay. Public static to do. And then private void awake.
So let's go back over here onto our unit move script, and when getting the target position, let's go inside the mouse position, access the static instance, and call get position. And yeah, just like this.
Okay, so dots player, we're going to we need an entity. Okay, create new mono behavior script. Dots player authoring. Okay, dots player authoring. Do we need a authoring script to use as our template? So we're going to bring this into here. This is not supposed to be this. This is supposed to be dots player. And then we're just going to do this. There we go. Okay. Okay, sorry about that. Okay, now we can do this because we're not passing anything through there like that. There we go.
This unit should be going towards the mouse position. Let's make sure it's
Then we need an I system. Dots player system. Okay, and then we're going to move that over onto another screen so we can just have access to it real quick here because we're just going to be doing that. So he's just got this like so on destroy. We don't need that. And then here we've got for each ref RW local transform. System API. Then we do dots controller dot instance dot get inputs. Ah, I see what's going on here. Can I just do a random struct? There. Check input. No, this needs to be get. Get input values. This would be player dots player input values. Oh, these need to be float threes. Oh, wait. This needs to be a... So what? Unity. This is a float 4. No, I don't want to do that. But this is a unity dot mathematics dot float. Oh, no, okay, so it's just float, okay. That works for me. That's not right. Dots player. No, this is all local transform. Local transform is input values dot gas value. Okay, and then Unity basic character controller.
Script named character. For that we input, then we variable and use it in the move command.
Move time dot delta.
And
I'm gonna say times 5. Times system API dot time dot delta time times forward. That's not really what we want. Where's the move character? Move speed. That's the authoring. It's this one here. Okay, so this becomes the target position is going to be a new float, right? Which is going to be local transform dot position dot forward dot up. Wait. Local transform dot forward times input value dot gas value. What value, gas value, local move direction. I think this might be it. Wait, if I do this the other way, will it work? Sorry, give me a second here. It could be an order of operations, but I don't think it is. And import missing. Cannot operate multiplication. Cannot operate multiplication operands of type float on a method group. This would be Z. I want to say this is Z, right? Or this whatever forward is. If we do a new float float 3, we can just do this for all of them, right? Is local transform not a float 3? Oh, that's why. Okay. Public float, get gas. Move direction. To do float value. Float steer value. Get steering value. Move direction math.up. physics velocity. Okay, yeah. So we've got that, and what I think I want to do is take this and move this here, but then move this one here. So we're going to move these two into each other's spots. And then here, yeah, we need a physics ref RW. Physics velocity. Velocity. Then we need the same thing up here. And this needs to be physics velocity. And what did we get wrong here? Cannot. Oh, this is read only. Read only. Yeah, there we go. Oh, wait, no, that is read write. Maybe? I don't actually know. Move speed will be 4. Move to, here's our dots player. Then we're going to take this here, add a rigid body, right? Beautiful. going to take this dots here and we're going to move it into, we're going to call this here, wait. This is the dots player controller. I'm going to take this here and move it into here, and we're going to rename this to dots player. Player character. We're going to save. We're going to hit play. I should at least be able to go forward or some random direction. I don't actually know. Unassigned reference variable and camera. Oh, right. But yeah, that's fine. Main camera. Oh, right. I don't have all of the stuff attached to him. Yeah, I don't. Okay. Project. Dots player. It worked. It frickin' worked. Now I wonder if the main camera can be in here. I just go like that, right? And then, and I'll just, can I just clear these? 0, 0, 0. There we go. And then 0, 0. Then we're going to do create empty mesh just for now. Can I just move that there? Oh, okay. Okay, so here we do rigid body and box collider. And then here we also do we do the mesh filter and all of that. Mesh filter and mesh renderer. We're just going to pop these up here. And then here we're going to do box, cube, cube, cube. Material, we're just going to do maybe that. No, wait. We want whatever this one is, right? we go. Save. Someday over the rainbow. Huh. Is there like a compile error or something like that that I'm unaware of? No, I think Unity just stopped responding. What's up, Don? How's your Friday been? Okay, there we go. Then we go to the dots player controller and we're just going to remove this. Remove component. Remove component. Remove component and remove component. And then we're going to save. Stream today went really good. I like diving deeper into the back end. How's yours been? I found out that all of the work that I did to get the vehicle working was useless because that the controller system for the vehicle doesn't work inside of dots, and and if you use dots, your character has to be in dots if you need physics. So if you have dots, the only way to have physics is to be in dots. And there isn't a vehicle controller inside of dots. So I have to build a vehicle controller inside of dots in order for it to work. 2 days. So 16 hours. To be fair, I can replicate that controller now very quickly. The issue was that I was also learning how to use Unity at the same time, right? So I don't know. It sounds worse than it is. But check this out. If this works, which I think it should. No, it's not working. Wait, what? Okay. Wait. If I can get this to work. Oops. Which I think I can. Okay, here's my controller. We want to move this guy around so he's facing this direction. And then we'll move him back a bit more. There we go. Save. Okay, and then we hit play. Look at that go. We somehow have an extra controller though. I don't know how we ended up with two. That's an interesting situation. There we go. Save. So if I go here, oh, that's why. Okay. Okay, so this one needs to have the okay. So this is the problem here. This needs to be removed. This also needs to remove. Then we do this. We zoom in on this mesh here. And then we're going to add component mesh collider. Or sorry, we should be able to do just convex, right? No. Move. Rigid body. There. And then add component box collider. There we go. Save. Damn it. Yeah, right. All right. So remove. Oh, wait. I added them to the wrong thing. That's why. Box collider. Yeah, there we go. And rigid body. And then we hit play. Now I should drop. So my box should drop down to the floor. There. But now I can... Why am I moving the wrong direction? Damn it. Look at that. Beautiful. I made a thing. Wait, what's going on here? The camera is not attached to the mesh, I guess. Maybe if I do this. Okay. I've seen the error of my ways. 0, 0. Zero, zero, zero. On 180. There we go. Then we're gonna zoom down. And then we can zoom back and down maybe. There. And save and hit play. We should now be able to see at least go forward. There he is. So we've made progress. Bye box. And as you can see, the characters are spawning just fine. The pedestrians are spawning at record numbers. We can actually have more pedestrians right now than we can in Unreal, which is kind of crazy and amazing. I love it. So Monday, we're going to be back on Monday. Yeah. And on Monday we will focus entirely on the actual movement of the character. So that should be happy, good fun times. In the meantime, thank you to everybody who showed up and chatted and lurked and all of that. You were all awesome. And we're gonna call it a night here, and head out and whatnot. So I'll see you all on Monday. Ta-ta for now.